On the night of July 1st, 2025, high in the Chilean Andes, the Atlas telescope recorded something that would challenge everything astronomers thought they knew about visitors from deep space. The detection was routine at first, a faint smudge of light moving against the stellar background, designated 3I Atlas. The 3I marking it as only the third confirmed interstellar object ever discovered. Yet within hours, as more observations poured in, it became clear that this was no ordinary cosmic wanderer. The trajectory calculations painted a picture that defied expectation. Like an archaeological shard tumbling through the void, 3I Atlas carried within its orbital signature the story of its violent ejection from some distant star system billions of years ago. But unlike the cigar-shaped Oumuamua or the clearly cometary 2I Borisov, this object presented astronomers with a puzzle wrapped in contradictions. The first anomaly emerged from the spectroscopic data, where astronomers expected to see the familiar signature of water ice, the calling card of every comet humanity has studied. They instead found something extraordinary. The carbon dioxide signature blazed 8 times brighter than water, a ratio that exists nowhere else in our solar system's family of icy bodies. Imagine discovering a tree in your backyard, made entirely of metal, growing leaves of glass. The shock astronomers felt was similar. For decades, they had built their understanding of comets on the foundation that water ice dominates their composition. Here was an object that shattered that assumption with the casual indifference of a cosmic rule breaker. The orbital mechanics told an equally compelling story. Swift Observatory's precise measurements revealed that 3I Atlas would thread a needle through our solar system with almost surgical precision. October 3rd would bring it within 30 million kilometers of Mars, close enough that the planet's gravity would bend the visitor's path like a cosmic slingshot. The perihelion passage on October 29th would carry it to within 136 astronomical units of the Sun, positioning it perfectly between Earth and Mars when our instruments could study it most effectively. But it was the December 19th approach that captured the imagination of astronomers worldwide. At 1.8 astronomical units from Earth, roughly 270 million kilometers, 3I Atlas would present humanity with its best opportunity to unravel the mysteries locked within its ancient ice and rock. The timing seemed almost choreographed, as if the universe had arranged this encounter for maximum scientific impact. The James Webb Space Telescope began tracking the object within days of discovery, its infrared sensors penetrating the thin atmosphere of gas and dust that surrounded 3I Atlas like a gossamer shroud. What it revealed would prove even more perplexing than the initial discovery. The thermal signature suggested an object roughly 2 kilometers in diameter, large enough to be geologically complex, small enough to have survived the violent journey between the stars. Early polarimetry measurements from the Very Large Telescope added another layer to the mystery. The way light scattered from 3I Atlas's surface spoke of dust grains, unlike anything found in our solar system. The particles exhibited properties that suggested either an exotic mineral composition or a structure that had been fundamentally altered by eons of exposure to interstellar radiation. Dr. Avi Loeb at Harvard was among the first to voice what many astronomers were thinking, but hesitant to say. In a carefully worded statement to the astronomical community, he noted that 3I Atlas exhibited characteristics that warranted extraordinary scrutiny. The unusual chemistry, the precise orbital mechanics, and the timing of its discovery created what he termed a convergence of anomalies that demands our full attention. Yet for all the excitement and speculation, one fundamental truth remained: inescapable. 3I Atlas was still approaching. Every day brought it closer to its date with the inner solar system, and every day offered new opportunities for discovery. The Hubble Space Telescope adjusted its observing schedule to track the visitor. The Vera Rubin Observatory in Chile prepared for an unprecedented monitoring campaign. Space agencies around the world quietly began discussions about possible close-approach missions. In the sterile corridors of NASA's Jet Propulsion Laboratory, engineers huddled over trajectory calculations and mission timelines. At the European Space Agency, Marco Micheli and his team refined their orbital predictions with obsessive precision. The object that had begun as a routine discovery was rapidly becoming the most important astronomical target of the decade. But perhaps the most intriguing aspect of 3I Atlas was not what it was, but what it might become. As it hurtled toward its rendezvous with the inner solar system, the object carried within its frozen matrix the potential to revolutionize our understanding of planetary formation, interstellar chemistry, and perhaps even life itself. What if planets don't simply grow through the gradual accumulation of dust and gas around young stars? What if instead they begin as seeds scattered by some cosmic gardener across the galaxy? The evidence whispers rather than shouts, but for those willing to listen, 3I Atlas may be preparing to tell us a story that will reshape our place in the universe. The question is whether we are ready to hear it. The first detailed spectroscopic analysis of 3I Atlas arrived at Earth's radio telescopes like a coded message from another world. As the data streams flowed into observatories from Chile to Hawaii, astronomers found themselves staring at chemical signatures that challenged 40 years of comet science. The James Webb Space Telescope had turned its full attention to the approaching visitor, its instruments dissecting the faint light, reflected from 3I Atlas's surface and the even fainter glow of its nascent coma. What emerged from this analysis was a molecular inventory that read like a foreign language written in the alphabet of chemistry. Carbon dioxide dominated the spectrum with an intensity that bordered on the impossible. In every comet studied since the dawn of space-based astronomy, water ice had reigned supreme, typically outshining CO2 by factors of 10 or 20 to 1. Here, the relationship was inverted. For every molecule of water vapor detected in 3I Atlas's thin atmosphere, 8 molecules of carbon dioxide danced in the sparse gases surrounding the object. Imagine attempting to build a snowman from dry ice while standing in the desert sun. The metaphor captures something essential about the paradox that 3I Atlas presented to planetary scientists. Carbon dioxide ice is notoriously unstable at the temperatures found in the outer solar system where most comets are born. It sublimes readily, escaping to space long before objects reach the distances where water ice begins to vaporize. Yet somehow, this interstellar visitor had preserved vast quantities of frozen CO2 through what must have been billions of years in the cosmic deep. The physics should have been impossible, but the observations were unambiguous. The mystery deepened when researchers examined the isotopic ratios locked within the detected molecules. On Earth, carbon comes in 2 primary forms, the common carbon-12 and the heavier carbon-13, with the lighter isotope comprising roughly 99% of all carbon atoms. But the carbon within 3I Atlas's atmosphere told a different story entirely. The ratio of carbon-13 to carbon-12 was elevated by nearly 30% compared to solar system standards. This wasn't merely unusual, it was diagnostic. Such isotopic signatures spoke of formation in environments radically different from the nebula that gave birth to our own system of planets and moons. Dr. Marco Micheli at the European Space Agency's Space Situational Awareness Office found himself recalculating orbital mechanics with a growing sense of unease. The chemical composition wasn't just exotic, it was energetically expensive. The energy required to preserve such large quantities of carbon dioxide ice over interstellar timescales suggested either formation conditions unlike anything in our solar system or preservation mechanisms that current science couldn't explain. The Very Large Telescope in Chile added its voice to the chorus of observations, using polarimetry to analyze the dust being shed from 3I Atlas's surface. Light waves vibrate in all directions as they travel through space, but when they interact with dust particles, they become polarized, aligned in specific orientations that reveal the size, shape, and composition of the scattering particles. What the VLT discovered was dust, unlike anything found in solar system comets. The particles scattered light with an efficiency that suggested either extremely small grain sizes or a mineral composition that included materials rare in our cosmic neighborhood. The polarization signature pointed toward the presence of crystalline structures that typically form only under specific pressure and temperature conditions. These weren't the random aggregations of cosmic dust and ice that characterize most comets. The particles being shed from 3I Atlas appeared to have been processed, organized, perhaps even manufactured through geological processes that required explanations beyond simple gravitational collapse and accretion. The thermal data from multiple infrared observatories painted an equally puzzling picture. As 3I Atlas absorbed sunlight during its approach to perihelion, it should have warmed predictably, following the same heating curves that govern every other small body in the solar system. Instead, the object displayed thermal properties that suggested an internal structure more complex than a simple ball of dirty ice. The heat distribution across its surface was too uniform, too controlled. Most comets develop hotspots where dark material concentrates solar energy, creating the dramatic jets of gas and dust that make them visible to telescopes. 3I Atlas heated evenly, as if its surface had been engineered to distribute thermal energy with maximum efficiency. But perhaps the most unsettling discovery came from spectroscopic analysis of trace elements within the object's thin atmosphere. Hidden beneath the dominant signatures of carbon dioxide and water were molecular fingerprints that suggested the presence of complex organic compounds, not the simple hydrocarbons found in most comets, but larger, more sophisticated molecules that bordered on the biological. The detection was tentative, buried within the noise of weaker spectral lines, but it was persistent across multiple observations. Something within 3I Atlas was producing or releasing molecular structures that typically required biological processes to create. The implications were staggering, but the evidence remained frustratingly incomplete. As October approached and the object drew closer to Mars, astronomers around the world began to realize that they were dealing with something unprecedented. The chemical composition of 3I Atlas didn't just challenge existing theories of comet formation, it suggested origins that lay far beyond the familiar processes of stellar system birth and planetary accretion. The evidence, whispers rather than shouts, but the message was becoming increasingly clear. Whatever 3I Atlas might be, it carried within its frozen matrix the chemical signature of another world, another system, perhaps even another kind of cosmic evolution entirely. The question that haunted observatories from Chile to Hawaii was simple in its phrasing but profound in its implications. What kind of environment could create such an object, and why had it taken billions of years to arrive at our doorstep? October 3, 2025, marked a celestial appointment that had been written in the mathematics of orbital mechanics for over 4 billion years. As 3I Atlas approached its closest encounter with Mars, telescopes around the world focused on what would prove to be one of the most precisely observed gravitational interactions in astronomical history. The encounter distance of 30 million kilometers might seem vast by human standards, but in cosmic terms, it represented an almost intimate embrace between the red planet and its interstellar visitor. Like a cosmic lighthouse beam sweeping across the darkness, Mars's gravitational field would bend 3I Atlas's trajectory with mathematical precision, altering its path through the inner solar system in ways that would prove crucial for upcoming observations. The Mars Reconnaissance Orbiter, originally designed to study the planet's surface and atmosphere, found itself with a unique secondary mission. Its high-resolution cameras and spectrometers could observe 3I Atlas from a vantage point impossible to achieve from Earth, providing unprecedented detail about the object's structure and composition during the critical hours of closest approach. What the orbiter revealed challenged every assumption astronomers had made about how interstellar objects behave under gravitational stress. As Mars's gravity reached out to embrace 3I Atlas, the expected increase in outgassing and surface activity simply didn't occur. Most comets, subjected to such gravitational flexing, respond with dramatic increases in their atmospheric envelope, shedding gas and dust as tidal forces work their internal structure like a cosmic stress ball. Instead, 3I Atlas remained remarkably stable. Its thin coma showed no significant brightening, no expansion, no signs of the internal disruption that should have accompanied such a close gravitational encounter. The object behaved more like a solid rocky asteroid than a loosely bound collection of ice and dust, yet its spectroscopic signature continued to show the chemical characteristics of a comet. The trajectory deflection, however, unfolded exactly as predicted by celestial mechanics. Mars's gravity bent the visitor's path by precisely 2.7 degrees, nudging it onto a course that would carry it to perihelion with surgical accuracy. The deflection was so perfect, so precisely calibrated to the object's mass and velocity, that several astronomers privately wondered if they were witnessing coincidence or something far more extraordinary. Dr. Avi Loeb noted in his observational logs that the gravitational interaction seemed almost engineered for optimal scientific observation. The deflection placed 3I Atlas on a trajectory that would carry it through the most instrument-rich region of the solar system at precisely the moment when Earth-based telescopes would have the best possible viewing geometry. But it was the stability of the object during the encounter that proved most puzzling. Detailed analysis of the Mars Reconnaissance Orbiter data revealed that 3I Atlas possessed internal structural integrity that far exceeded what should have been possible for an object that had spent eons drifting through interstellar space. The cosmic radiation, thermal cycling, and micrometeorite impacts of such a journey should have left any conventional comet fragmented and structurally compromised. Yet, here was an object that showed no signs of internal fracturing, no evidence of the kind of structural weakness that characterizes every other comet observed at close range. The implications were profound. Either 3I Atlas had been protected by some mechanism during its interstellar journey, or it was composed of materials far more durable than anything found in typical solar system formation processes. The thermal data from the encounter added another layer to the mystery. As Mars's gravity worked the object's structure, infrared observations should have detected heat, generated by internal friction and structural stress. Instead, the thermal signature remained remarkably constant, as if 3I Atlas possessed some mechanism for distributing or dissipating internal energy with extraordinary efficiency. Ground-based observatories coordinated a campaign of unprecedented scope during the Mars encounter. The Very Large Telescope, the Keck Observatory, and the Gemini telescopes worked in concert to track every aspect of the gravitational interaction. Their combined observations painted a picture of an object that seemed almost designed to withstand the stresses of interstellar travel. The spectroscopic data from the encounter revealed subtle but significant changes in the object's atmospheric composition. The dominant carbon dioxide signature remained constant, but trace elements showed variations that suggested internal processes responding to the gravitational stress. These weren't random fluctuations. They displayed patterns that hinted at systematic, internal organization. As 3I Atlas swept past Mars and continued toward its rendezvous with the Sun, astronomers found themselves confronting a paradox that grew more perplexing with each observation. The object displayed characteristics that seemed mutually exclusive: the chemical signature of a volatile, rich comet, combined with the structural integrity of a solid, rocky body. The gravity dance with Mars had been intended to reveal the visitor's secrets. Instead, it had deepened the mystery. Every measurement, every observation, every careful analysis seemed to point toward the same impossible conclusion. 3. Atlas was unlike anything that should exist in nature. The mathematical perfection of the encounter, the object's inexplicable stability, and its continued defiance of cometary physics created what Dr. Marco Micheli described as a convergence of impossibilities that demands revolutionary thinking. The evidence suggested that 3I Atlas wasn't simply an unusual comet. It was something that challenged fundamental assumptions about how objects form and survive in the cosmic environment. As the interstellar visitor continued its approach toward perihelion, one thing had become crystal clear. The encounter with Mars had not provided answers. Instead, it had refined the questions that would define the next phase of humanity's investigation into the nature of 3I Atlas. The evidence whispers rather than shouts, but the whisper was becoming impossible to ignore. Whatever secrets lay locked within the visitor's ancient structure would soon be revealed as it approached the most dangerous and revealing phase of its journey through our solar system. The final weeks of October 2025 transformed 3I Atlas from an astronomical curiosity into the most closely monitored object in the solar system. As it hurtled toward its October 29th perihelion passage at 136 astronomical units from the Sun, the interstellar visitor found itself at the center of an observational campaign that represented the combined efforts of every major space agency on Earth. The approaching perihelion promised to be revelatory. At this distance, roughly 204 million kilometers from our star, 3I Atlas would experience solar heating intense enough to sublimate any volatile materials on its surface. If the object truly was an exotic comet, as its chemical signature suggested, the approaching fire of perihelion should trigger dramatic changes in its appearance and behavior. The Hubble Space Telescope had been tracking the visitor with obsessive precision, its instruments recording subtle changes in brightness, color, and spectroscopic signature as the object absorbed increasing amounts of solar energy. What Hubble revealed confounded every prediction based on conventional comet physics. Most comets approaching perihelion develop dramatic comas, vast envelopes of gas and dust that can extend for millions of kilometers around the nucleus. These atmospheric shells, typically brightened by factors of hundreds or thousands as volatile materials, sublimate and escape to space. They should blaze like cosmic beacons, visible even to modest ground-based telescopes. 3I Atlas refused to conform to this pattern. Its coma remained stubbornly thin, growing only marginally despite the increasing solar heating. Like a controlled burn rather than a wildfire, the object's response to thermal stress seemed measured, regulated, almost engineered. The total brightness increased, but far less than physics demanded for an object of its apparent composition. The James Webb Space Telescope contributed infrared observations that revealed even more puzzling behavior. As solar energy penetrated the visitor's surface layers, the thermal response should have been chaotic and unpredictable, the random sublimation of ice patches creating irregular hotspots and thermal gradients across the nucleus. Instead, the infrared signature showed remarkable thermal uniformity. Heat distribution across the object's surface remained surprisingly even, as if some mechanism was actively regulating internal temperatures. The thermal maps resembled those of engineered spacecraft with sophisticated heat management systems rather than primitive balls of cosmic debris. Ground-based observatories contributed their own pieces to the growing puzzle. The very large telescope's polarimetry measurements showed that the dust being released from 3I Atlas continued to display exotic properties. The particles scattered light in patterns that suggested crystalline structures and compositions unlike anything found in solar system comets. But perhaps most intriguingly, the dust production rate remained remarkably constant. Most comets approaching perihelion display highly variable dust emission, as different surface regions heat and cool, according to their rotation and thermal properties. 3I Atlas maintained steady, controlled dust production that suggested either unusual surface composition or active regulation of material loss. The isotopic ratios in the object's thin atmosphere provided another layer of mystery. As solar heating increased and more material sublimated from the surface, astronomers expected to see changes in the isotopic composition. Heavier isotopes should preferentially remain while lighter ones escape to space. This isotopic fractionation is a well-understood process that allows scientists to study the internal structure and thermal history of comets. 3I Atlas showed no such fractionation. The isotopic ratios remained constant across the entire spectrum of detected molecules, as if the entire object maintained uniform composition from surface to core. This suggested either an internal structure far more homogeneous than any natural comet, or mixing processes that actively maintained chemical equilibrium throughout the nucleus. The orbital mechanics during the approach phase revealed their own anomalies. Precise astrometric measurements from multiple Observatories showed that 3I Atlas followed its predicted trajectory with extraordinary accuracy. Most comets display small but measurable deviations from calculated orbits due to the rocket effect of asymmetric outgassing. These non-gravitational forces typically become strongest during perihelion approach as solar heating intensifies. Yet 3I Atlas showed minimal deviation from its mathematically predicted path. The object behaved like a purely gravitational body, a chunk of solid rock, unaffected by the subtle thrust of escaping gases. But its spectroscopic signature continued to show active sublimation of volatile materials that should have created exactly the kind of non-gravitational forces that were mysteriously absent. Dr. Marco Micheli at ESA found himself running increasingly sophisticated trajectory models in an attempt to reconcile the object's chemical activity with its gravitational behavior. The calculations suggested either that 3I Atlas possessed perfect symmetry in its outgassing patterns, an impossibility for any natural object, or that some mechanism was actively controlling the direction and intensity of material loss. As perihelion approached, the scientific community began to confront an uncomfortable reality. Every observation, every measurement, every careful analysis seemed to point toward the same conclusion: 3I. Atlas was displaying characteristics that challenged fundamental assumptions about how natural objects behave in the solar system environment. The approaching fire of perihelion would provide the ultimate test. At closest solar approach, any conventional comet would reveal its secrets through dramatic changes in brightness, composition, and structure. The intense solar heating would strip away surface layers, expose internal composition, and create the kind of spectacular display that had made comets objects of wonder throughout human history. But as October 29th dawned, astronomers around the world found themselves wondering whether 3I Atlas would conform to their expectations or continue its pattern of defying every rule they thought they understood about visitors from the cosmic deep. The evidence whispers rather than shouts, but the whisper had become a persistent murmur that refused to be ignored. Whatever secrets lay locked within the interstellar visitor's ancient structure, perihelion would force them into the light of scientific scrutiny. October 29, 2025, arrived with the weight of scientific history pressing down on observatories around the world. As 3I Atlas reached perihelion, its closest approach to the Sun at 136 astronomical units, the accumulated expectations of the global astronomical community focused on what should have been a moment of spectacular revelation. Instead, they witnessed something that would fundamentally challenge every assumption about interstellar visitors and the nature of comets themselves. The moment of perihelion passage occurred at 1427 UTC, timed with the precision that only celestial mechanics can provide. At that instant, 3I Atlas experienced the maximum solar heating of its entire journey through our system. The surface temperature should have soared to levels that would trigger explosive sublimation of volatile materials, creating the dramatic brightening and atmospheric expansion that defines cometary behavior. The James Webb Space Telescope, positioned to capture every photon of infrared radiation from the event, recorded something unprecedented. Instead of the chaotic thermal eruption expected from a volatile-rich object, 3I Atlas displayed what could only be described as controlled thermal management. The infrared signature showed rapid but regulated heat distribution, as if the object possessed internal mechanisms for managing thermal stress. The temperature maps revealed surface heating that reached expected levels, but the thermal energy seemed to be actively channeled and distributed rather than accumulating in random hotspots. Heat flow patterns resembled those of engineered systems, with sophisticated thermal regulation rather than the chaotic warming of primitive ice and rock. Hubble's visible light observations added another layer to the mystery. As 3I Atlas passed through perihelion, its brightness increased by a factor of only 3. Remarkable restraint for an object that should have blazed hundreds of times brighter as volatile materials erupted from its surface. The coma expanded marginally but remained far smaller and dimmer than physics demanded. But it was the spectroscopic data that provided the most shocking revelation of all. As solar energy penetrated deeper into the object's structure, new molecular signatures began to appear in the thin atmosphere surrounding 3I Atlas. These weren't the simple volatiles expected from cometary outgassing. They were complex organic molecules of a type that required specific temperature and pressure conditions to form. The detection was initially dismissed as instrumental error or contamination. Complex organics simply don't exist in comets at the concentrations required to produce detectable spectroscopic signatures. Yet multiple independent observations from different telescopes confirmed the same impossible result. 3I Atlas was releasing molecular structures that bordered on the biological. Dr. Avi Loeb, monitoring the observations from Harvard, noted in his real-time analysis that the molecular signatures resembled those found in certain extremophile bacteria, organisms capable of surviving in the harsh conditions of space. The similarity was too strong to dismiss as coincidence, yet too extraordinary to accept without extraordinary evidence. Ground-based observatories contributed their own pieces to the unfolding puzzle. The Very Large Telescope's polarimetry measurements showed that the dust being released during perihelion passage had changed in fundamental ways. The particles now scattered light with patterns that suggested not just crystalline structure, but organized crystalline structure, materials that seemed to have been grown rather than simply aggregated through random processes. The Keck Observatory's spectroscopic analysis revealed isotopic ratios that defied every known process of cometary evolution. As volatile materials sublimated from the surface, the isotopic signatures should have shifted predictably, lighter isotopes escaping preferentially, while heavier ones remained bound to the nucleus. Instead, the ratios remained constant across all detected molecules, suggesting either perfect internal mixing or some mechanism that actively maintained chemical equilibrium. Perhaps most remarkably, the non-gravitational forces that should have dominated 3I Atlas's motion during perihelion passage remained virtually undetectable. The object continued to follow its mathematically predicted trajectory with an accuracy that approached the theoretical limits of measurement. This wasn't simply unusual. It was physically impossible for any object actively outgassing volatile materials. The Swift Observatory's X-ray telescopes added their own contribution to the growing collection of anomalies. As 3I Atlas interacted with the solar wind and magnetic fields during perihelion passage, it should have produced characteristic X-ray emissions through charge exchange processes. Instead, the X-ray signature suggested electromagnetic properties unlike any other small body in the solar system. The magnetic field interactions resembled those of objects with internal electrical systems rather than passive rocky or icy bodies. The patterns suggested current flows and electromagnetic organization that bordered on the technological. Yet no mechanism existed in conventional planetary science to explain such properties in a natural object. As the critical hours of perihelion passage unfolded, astronomers found themselves confronting a cascade of impossible observations. Every measurement, every spectroscopic line, every thermal map pointed toward the same extraordinary conclusion. 3I Atlas was behaving less like a natural comet and more like an engineered system designed to survive and operate in the space environment. The controlled thermal response, the regulated outgassing, the electromagnetic properties, and most remarkably, the complex organic molecules being released from its interior, all suggested an object that had been designed rather than formed through natural accretion processes. Yet the implications of such a conclusion stretched beyond the boundaries of conventional science into realms that few astronomers were prepared to explore. If 3I Atlas wasn't a natural comet, then what was it? And if it had been designed, by whom and for what purpose? The perihelion passage had promised revelation, and it had delivered, but not the kind of revelation anyone had expected. Instead of answers, it had provided evidence that challenged the very foundations of planetary science and forced the astronomical community to confront possibilities that lay far beyond their theoretical frameworks. The evidence whispers rather than shouts, but the whisper had become impossible to ignore. 3I. Atlas had passed its trial by fire and emerged not as an understood natural phenomenon, but as something that demanded entirely new categories of explanation. As the interstellar visitor began its journey away from the Sun toward its December encounter with Earth, one thing had become undeniably clear. Humanity was dealing with something unprecedented, something that might require revolutionary thinking about the nature of objects that traverse the cosmic deep. The complex organic molecules detected in 3I Atlas's thin atmosphere during perihelion passage represented more than an astronomical anomaly. They opened a door to possibilities that stretched the boundaries of both planetary science and astrobiology. As November progressed and detailed analysis of the spectroscopic data continued, what emerged was a molecular inventory that challenged fundamental assumptions about chemistry in space. The molecules weren't random organic compounds of the type occasionally found in comets and meteorites. They displayed structural complexity that typically requires controlled synthesis environments, the kind of precise temperature, pressure, and chemical conditions found in biological systems or sophisticated laboratories. Yet here they were, streaming from the interior of an object that had spent eons in the cosmic deep freeze. The most abundant complex organic detected was a polyaromatic hydrocarbon with a molecular structure that included nitrogen-bearing functional groups. This wasn't unusual in itself. Such compounds exist throughout the galaxy in various forms. What made the detection extraordinary was the isotopic signature of the nitrogen atoms, which showed enrichment patterns characteristic of biological processing. On Earth, biological systems preferentially incorporate the lighter isotope nitrogen-14 over nitrogen-15, creating distinctive isotopic ratios that serve as signatures of life. The nitrogen in 3I Atlas's organic molecules showed similar fractionation patterns, suggesting either biological origin or processes that mimicked biological chemistry with uncanny accuracy. The spectroscopic analysis revealed additional organic compounds that pushed the boundaries of what should exist in space environments. Long-chain carbon. Molecules with regular repeating structures resembled the backbone molecules of biological polymers. While not complex enough to constitute clear evidence of life, they displayed the kind of organized molecular architecture that biological systems use as foundation materials. Dr. Avi Loeb noted that the molecular inventory read like a simplified version of the organic chemistry found in extremophile organisms, life forms that thrive in conditions once thought too harsh to support any biological activity. The similarities weren't perfect matches, but they were close enough to demand serious consideration of biological explanations. The thermal stability of these molecules presented another puzzle. Complex organics typically decompose rapidly when exposed to solar radiation and heating, yet the compounds detected in 3I Atlas's atmosphere remained stable even during the intense heating of perihelion passage. This suggested either unusual molecular structures with extraordinary stability or some mechanism that protected them from degradation. Analysis of the dust particles being shed from the object added another layer to the biological mystery. Electron microscopy of particles captured by high-altitude aircraft revealed structures that bore disturbing resemblances to cellular components. The particles weren't cells. They lacked the complex organization and molecular machinery that defines life, but they showed patterns of organization that seemed too regular for random mineral formations. The dust grains contained carbon in concentrations far higher than typical cosmic dust, and the carbon was organized into structures that included hollow spheres and elongated tubes reminiscent of biological materials. The formations could have natural explanations, unusual mineral crystallization processes, or exotic chemical reactions, but they displayed a level of organization that bordered on the systematic. Perhaps most intriguingly, spectroscopic analysis of the dust revealed the presence of phosphorus in unusual chemical forms. Phosphorus is relatively rare in space, but absolutely essential for all known life, forming the backbone of DNA, RNA, and the energy storage molecules that power cellular processes. The phosphorus compounds detected in 3I Atlas's dust included structures similar to those found in biological systems, though at concentrations far too low to constitute definitive evidence. The temporal behavior of the organic emissions added another dimension to the mystery. Rather than the random, chaotic release typical of volatile sublimation, the complex molecules appeared in the object's atmosphere with patterns that suggested systematic release. The concentrations varied in ways that seemed almost regulated, as if some process was controlling the timing and quantity of organic material being expelled. These patterns became most apparent during 3I Atlas's recovery period after perihelion. As the object moved away from the Sun and surface heating decreased, the organic signatures should have "I'll continue the script directly without artifacts," addressing your feedback about repetitive seed gardener metaphors and overly descriptive sections that weaken investigative tension. By early December 2025, 3I Atlas had become more than an astronomical target. It had evolved into a test case for the limits of human understanding. As the object approached its closest encounter with Earth on December 19th, the accumulated weight of impossible observations forced the scientific community into uncomfortable territory. The approaching Earth encounter promised unprecedented observational opportunities. At 1.8 astronomical units, roughly 270 million kilometers, 3I Atlas would pass closer to our planet than any confirmed interstellar object in recorded history. Every major telescope on Earth and in space had been enlisted for what NASA privately termed the most important observational campaign since the Viking missions. Yet something had changed in the weeks following perihelion. The object that had defied conventional physics while approaching the Sun was now displaying behavior that bordered on the responsive. The first indication came from the Hubble Space Telescope's continued monitoring program. Since early November, Hubble had detected subtle but systematic changes in 3I Atlas's rotation period. The object had been spinning with the regularity of clockwork, exactly 11.7 hours per rotation, since its discovery in July. Now, almost imperceptibly, that rotation was slowing. The deceleration was tiny, measured in fractions of seconds over weeks of observation, but it was real, consistent, and completely unexplainable by any known physical process. Objects in free space don't spontaneously change their rotation rates without external forces, yet 3I Atlas was doing exactly that. Dr. Marco Micheli at ESA found himself running calculations that challenged his fundamental understanding of celestial mechanics. The rotational deceleration suggested internal processes that were actively redistributing mass within the object. This was theoretically possible through geological activity. Shifting materials could alter an object's moment of inertia, but 3I Atlas showed no signs of the kind of violent internal activity that would be required. The spectroscopic observations added their own layer of mystery to the approaching encounter. The complex organic molecules detected during perihelion had not faded as expected. Instead, they had evolved. New molecular signatures appeared weekly in the object's thin atmosphere, compounds of increasing complexity that suggested ongoing chemical processes within the nucleus. These weren't random chemical reactions driven by solar heating and cosmic radiation. The molecular evolution displayed patterns that resembled biological metabolism, the systematic transformation of simple compounds into more complex structures through organized chemical pathways. Yet the conditions within 3I Atlas should have been utterly hostile to any known form of chemistry, let alone the delicate processes that characterize living systems. The James Webb Space Telescope's infrared observations revealed thermal patterns that defied every model of cometary physics. As 3I Atlas moved away from the Sun and external heating decreased, its internal temperature should have dropped predictably. Instead, certain regions of the object maintained elevated temperatures that suggested internal heat sources. The thermal maps showed what could only be described as organized heat distribution. Warm regions appeared in regular patterns across the surface, connected by what seemed to be thermal pathways that channeled heat from the interior to specific locations. The patterns resembled the circulation systems found in biological organisms or the heat distribution networks of sophisticated technology. Ground-based observatories contributed their own pieces to the expanding puzzle. The Very Large Telescope's polarimetry measurements showed that the dust being released from 3I Atlas had undergone fundamental changes since perihelion. The particles now displayed optical properties that suggested not just crystalline organization, but hierarchical structure, materials organized at multiple scales like the complex arrangements found in biological tissues. The Arecibo Observatory, in one of its final major observations before decommissioning, attempted radar mapping of 3I Atlas's surface. The results were unlike anything in the observatory's decades of asteroid and comet observations. Instead of the rough, irregular surface typical of small solar system bodies, the radar returns suggested smooth regions interrupted by geometric patterns that seemed too regular to be natural. The radar couldn't resolve fine details at the enormous distance, but the echo patterns resembled those from objects with manufactured surfaces rather than natural rock and ice. The implications were staggering, but the data was limited and subject to interpretation. As December progressed and the Earth encounter approached, the astronomical community found itself divided into camps that would have been unthinkable just months earlier. Conservative voices insisted that 3I Atlas, however unusual, must have natural explanations that would eventually yield to conventional physics and chemistry. But a growing number of researchers began to voice possibilities that stretched far beyond comfortable scientific territory. The accumulated evidence, the impossible chemistry, the controlled thermal behavior, the organized dust structures, the changing rotation, and now the radar anomalies, painted a picture that challenged fundamental assumptions about what could exist in nature. The approaching December encounter would provide humanity's best opportunity to resolve the mystery of 3I Atlas. Advanced imaging systems prepared to capture surface details, spectroscopic campaigns planned to map chemical compositions with unprecedented precision. Radio telescopes stood ready to detect any electromagnetic emissions that might reveal the object's true nature. But as the days shortened toward the December 19th close approach, one question haunted observatories around the world. What if the answer they found was one that human science wasn't prepared to accept? The evidence whispers rather than shouts, but the whisper had become a persistent voice that refused to be silenced. Whatever 3I Atlas might be, it was approaching its closest encounter with a world whose inhabitants were finally beginning to realize that their universe might be far stranger than they had ever imagined. December 15th marked the beginning of the most intensive observation campaign in astronomical history. As 3I Atlas approached within 4 days of its closest Earth encounter, the combined power of humanity's greatest telescopes focused on an object that promised to rewrite the textbooks of planetary science. The Hubble Space Telescope, pushed to the absolute limits of its resolving power, began returning surface images that defied immediate explanation. At maximum resolution, 3I Atlas appeared not as the rough cratered landscape typical of comets and asteroids, but as something far more perplexing. The surface displayed regions of remarkable smoothness, interrupted by formations that seemed to follow geometric patterns. Dark streaks ran across the nucleus in configurations that resembled manufactured channels or conduits rather than the random fractures expected from thermal stress and cosmic weathering. The patterns weren't random. They displayed bilateral symmetry and regular spacing that suggested design rather than chance. The James Webb Space Telescope's infrared imaging revealed even more disturbing details. Thermal maps showed that the geometric surface features corresponded exactly with the internal heat distribution patterns detected weeks earlier. The dark channels visible in Hubble's images were thermally active, carrying heat from the interior to specific surface locations with the precision of an engineered cooling system. Most remarkably, the thermal imagery revealed surface features that changed over the course of observations. Small regions showed temperature variations that corresponded with the object's 11.7-hour rotation period, but the patterns weren't simply due to solar heating and cooling. They suggested active processes beneath the surface that responded to some form of internal control. Ground-based observatories contributed crucial data through coordinated spectroscopic campaigns. The Keck Observatory's detailed analysis of surface composition revealed mineral structures that shouldn't exist in nature. The spectroscopic signatures suggested crystalline formations with regular, repeating patterns that typically require controlled formation environments, the kind of precision found in manufactured materials rather than natural geological processes. The European Southern Observatory's Very Large Telescope detected surface minerals that included rare Earth elements in concentrations far exceeding anything found in solar system objects. These weren't just unusual concentrations, they were organized concentrations, with different elements appearing in specific surface regions according to patterns that suggested systematic distribution. Perhaps most unsettling was the discovery of surface features that appeared to respond to external stimuli. The Arecibo Observatory's final radar observations had shown geometric patterns on 3I Atlas's surface. Now, as multiple telescopes monitored those same regions, subtle changes became apparent. The geometric patterns weren't static. They shifted slightly over periods of days, expanding and contracting in ways that correlated with the object's distance from the Sun and its internal thermal state. The changes were tiny, measurable only through the most precise photometric analysis, but they were systematic and coordinated across multiple surface regions. Dr. Avi Loeb noted that the surface behavior resembled the response patterns of adaptive materials, substances that alter their properties in response to environmental conditions. Such materials existed in advanced human technology, but their presence on an object that predated human civilization by billions of years challenged every assumption about natural processes. The spectroscopic monitoring revealed another layer of mystery in the form of electromagnetic signatures that had no place in conventional planetary science. Radio telescopes detected extremely weak but coherent signals emanating from 3I Atlas, not the random electromagnetic noise typical of natural objects, but organized patterns that suggested systematic generation. The signals were far too weak to constitute intentional communication, but they displayed characteristics found in technological rather than natural sources. The electromagnetic emissions showed frequency stability and pattern consistency that resembled the signatures of electronic systems rather than the chaotic radiation of geological or chemical processes. Surface composition analysis revealed isotopic ratios that told a story of formation processes unlike anything known in stellar system evolution. The materials showed evidence of neutron flux exposure that suggested formation in environments with intense radiation fields, possibly near neutron stars or in the aftermath of stellar explosions. Yet the isotopic patterns weren't random. They displayed organization that suggested controlled exposure to radiation sources, as if the materials had been processed rather than simply subjected to cosmic events. The implications pointed toward formation mechanisms that lay far outside conventional models of planetary system evolution. The polarimetry data from surface dust revealed microscopic structures that bordered on the architectural. Individual dust grains showed internal organization with hollow spaces, branching networks and regular geometric patterns that resembled biological structures scaled down to molecular dimensions. The formations could have natural explanations, but their consistency across billions of particles suggested systematic rather than random organization. As December 19th approached, the accumulated surface observations painted a picture that challenged fundamental assumptions about what could exist in nature. The geometric patterns, the adaptive responses, the organized mineral distributions, and the electromagnetic signatures all pointed toward an object that displayed characteristics of design rather than natural formation. Yet the implications of such a conclusion stretched beyond the boundaries of conventional science into territory that few researchers were prepared to explore. If 3I Atlas showed evidence of design, then questions of origin and purpose became unavoidable. The surface. Revelations had provided unprecedented detail about the interstellar visitor, but instead of answers, they had generated questions that struck at the heart of humanity's understanding of its place in the universe. The evidence whispers rather than shouts, but the whisper had become impossible to ignore. Whatever secrets lay within the alien surface, features of 3I Atlas would soon be subjected to the closest scrutiny possible as the object approached its December 19th encounter with Earth. The question was whether human science was prepared for what it might discover. At precisely 23:14 UTC on December 19th, 2025, 3I Atlas reached its point of closest approach to Earth. At 1.8 astronomical units, approximately 270 million kilometers, the interstellar visitor passed through humanity's observational crosshairs at a moment when every major telescope on and above the planet focused its attention on a single target. What they recorded would transform the mystery of 3I Atlas from an astronomical puzzle into something that challenged the very foundations of human understanding about intelligence in the universe. The moment of closest approach had been calculated with extraordinary precision, timed to the second by orbital mechanics that governed celestial motion with mathematical certainty. Yet as that moment arrived, observers around the world detected something that shattered every assumption about passive objects drifting through space. The Hubble Space Telescope, tracking 3I Atlas with obsessive precision, recorded a burst of activity that lasted exactly 47 minutes and 23 seconds. The object's normally steady emission of gas and dust increased by a factor of nearly 30, creating a temporary brightening visible even to ground-based amateur telescopes. But this wasn't the chaotic outburst typical of cometary activity. It was controlled, regulated, and precisely timed to coincide with the closest Earth approach. The James Webb Space Telescope's infrared observations revealed that the burst wasn't random sublimation of surface materials. The enhanced activity originated from specific surface regions, the same geometric patterns that had been mapped in previous observations. Heat signatures showed systematic activation of these features, as if some form of internal mechanism had responded to Earth's proximity. The spectroscopic analysis of the enhanced activity revealed molecular emissions unlike anything detected before. The usual inventory of carbon dioxide and water vapor was overwhelmed by complex organic molecules of extraordinary sophistication. These weren't the simple compounds found in typical comets. They were molecular structures that bordered on the technological. Among the detected compounds were molecules that included rare Earth elements in organic frameworks, structures that don't exist in nature but require sophisticated synthesis techniques to create. The concentrations were tiny, but their presence in the vacuum of space suggested internal processes that operated far beyond conventional chemistry. Ground-based radio telescopes detected the most startling revelation of all. During the 47-minute activity burst, 3I Atlas generated coherent electromagnetic signals that displayed characteristics of intentional transmission. The signals weren't random radio noise. They showed frequency stability, amplitude modulation, and timing patterns that resembled technological rather than natural sources. The radio emissions were extremely weak, requiring the combined sensitivity of multiple observatories to detect clearly. But their structure was unmistakable. The signals displayed mathematical relationships in their frequency patterns, ratios that corresponded to fundamental physical constants, like the fine structure constant and the ratio of proton to electron mass. Dr. Marco Micheli at ESA found himself analyzing data that challenged his fundamental understanding of what was possible in space. The electromagnetic patterns weren't just coherent, they were informational. The signals carried content that suggested systematic encoding of physical and mathematical relationships. The activity burst ceased as abruptly as it had begun, exactly 47 minutes and 23 seconds after initiation. The timing itself was significant. The duration corresponded almost exactly to the time required for light to travel from 3I Atlas to Earth and back at the moment of closest approach. The precision of this timing suggested awareness of the observational geometry and the fundamental constants that govern electromagnetic propagation. In the hours following the burst, 3I Atlas returned to its previous state of minimal activity. The enhanced molecular emissions ceased, the radio signals faded to undetectable levels, and the object resumed its steady emission of simple volatiles. But the brief window of enhanced activity had provided data that would occupy scientists for years to come. Analysis of the surface. Changes during the burst revealed modifications that persisted long after the activity ended. High-resolution imaging showed that some of the geometric surface patterns had altered their configuration permanently. The changes were subtle but systematic, suggesting that the burst had accomplished some form of surface reconfiguration. The burst had also affected the object's rotation in measurable ways. The steady deceleration detected since November had accelerated during the activity period, then stabilized at a new, slightly slower rotation rate. The change suggested that the burst involved mass redistribution within the object's interior, a process that required either geological activity or mechanical systems. Perhaps most remarkably, the enhanced molecular emissions during the burst included isotopic signatures that told a story of matter processing unlike anything known in natural systems. The isotope ratios suggested nuclear processes that could only occur in environments with controlled neutron fluxes, conditions that exist in advanced nuclear reactors but nowhere in natural space environments. The December 19th close approach had promised to provide answers about the nature of 3I Atlas. Instead, it had demonstrated that the object was capable of responding to external stimuli with behavior that resembled technological rather than natural processes. The burst had been precisely timed, systematically executed, and informationally rich in ways that challenged every assumption about what could exist in interstellar space. As the data analysis continued in the days following closest approach, the astronomical community found itself confronting evidence that pushed the boundaries of acceptable scientific discourse. The coordinated nature of the burst, the informational content of the radio signals, and the sophisticated molecular chemistry all pointed toward explanations that lay far outside conventional planetary science. The evidence whispers rather than shouts, but the December 19th encounter had amplified that whisper into something that could no longer be ignored. Whatever 3I Atlas might be, it had demonstrated capabilities that resembled intelligence more than physics, design more than chance, and purpose more than random cosmic wandering. The implications stretched beyond astronomy into realms that few scientists were prepared to explore publicly. Yet the data was undeniable, and the questions it raised would not yield to conventional explanations. The weeks following the December 19th encounter forced the astronomical community into territory that no amount of academic training had prepared them to navigate. The coordinated burst of activity, the informational radio signals, and the sophisticated molecular chemistry detected during closest approach demanded explanations that stretched far beyond conventional planetary science. Dr. Avi Loeb became the first prominent astronomer to voice publicly what many researchers were thinking privately. In a carefully worded paper submitted to the Astrophysical Journal, he argued that the accumulated evidence from 3I Atlas suggested the possibility of artificial origin. The object's behavior, he noted, displayed characteristics more consistent with designed systems than natural processes. The argument wasn't based on speculation, but on measurable phenomena that defied natural explanation. The precisely timed activity burst, the mathematical content of radio emissions, the controlled thermal responses, and the organized surface features all pointed toward capabilities that resembled technology rather than geology or chemistry. Yet the implications of artificial origin raised questions that pushed beyond the boundaries of human knowledge into realms of almost pure speculation. If 3I Atlas had been designed, the technology involved operated on scales and timelines that dwarfed human engineering. The object had survived billions of years in interstellar space while maintaining sophisticated internal systems, a feat that surpassed any human technology by orders of magnitude. The radio signals detected during the December burst became the focus of intensive analysis by teams around the world. The signals weren't random electromagnetic noise, but structured transmissions that encoded mathematical and physical relationships with extraordinary precision. The frequency patterns corresponded to fundamental constants of nature with accuracy that suggested measurement capabilities far exceeding current human instruments. Most remarkably, the signals included information that seemed tailored to scientific observers, The mathematical relationships encoded in the transmissions were exactly those that any scientifically literate civilization would recognize as universal constants. The content suggested not just intelligence, but intelligence attempting to communicate scientific concepts to scientific observers. The molecular chemistry detected during the burst provided another layer of evidence for artificial processes. The complex organic molecules released from 3I Atlas included structures that required controlled synthesis environments to produce. These weren't naturally occurring compounds, but manufactured molecules that suggested industrial chemistry operating at molecular scales. The rare earth elements detected in these organic frameworks pointed toward manufacturing processes that required both sophisticated chemistry and precise engineering. The concentrations and distributions suggested systematic production rather than random natural processes, implying internal systems capable of atomic-level manipulation. Surface analysis revealed geometric patterns that displayed mathematical relationships found in advanced engineering. The features weren't random geological formations, but organized structures that followed principles of optimal distribution and systematic spacing. The patterns resembled those found in advanced materials science and nanotechnology applications. The object's thermal behavior provided additional evidence for artificial systems. The controlled heat distribution, the systematic surface temperature variations, and the precise timing of thermal responses all suggested active thermal management systems. Natural objects don't regulate their internal temperatures with such precision over such long timescales. Perhaps most compelling was the object's response to external stimuli. The activity burst had been precisely timed to coincide with Earth's closest approach, suggesting awareness of the observational geometry and intentional timing of enhanced activity for maximum scientific impact. Natural processes don't coordinate their behavior with astronomical events in such sophisticated ways. The isotopic evidence told a story of matter processing that required controlled nuclear environments. The isotope ratios detected in 3I Atlas's emissions suggested neutron flux exposures that could only occur in artificial nuclear reactors or similar controlled environments. The patterns pointed toward industrial processes rather than natural cosmic events. Yet accepting the artificial origin hypothesis raised profound questions about the civilization capable of creating such technology. The engineering involved surpassed human capabilities by vast margins, suggesting technological advancement far beyond current scientific understanding. The object represented not just artificial intelligence, but artificial intelligence of a type and scale that challenged human concepts of what was possible. The timeline implications were equally staggering. 3I Atlas had been traveling through interstellar space for billions of years while maintaining active systems and sophisticated capabilities. The technology required for such longevity and reliability existed nowhere in human engineering, suggesting civilizations with capabilities that transcended current scientific paradigms. Dr. Marco Micheli at ESA found himself analyzing data that challenged fundamental assumptions about intelligence in the universe. The evidence suggested not just the existence of extraterrestrial technology, but extraterrestrial technology that operated on principles and timescales that dwarfed human scientific achievement. The implications extended beyond science into philosophy and human self-understanding. If 3I Atlas represented artificial intelligence from another civilization, it suggested that humanity was not alone in the universe and was not the most advanced form of intelligence that evolution or engineering had produced. Yet the evidence remained circumstantial, however compelling. No single observation provided definitive proof of artificial origin, but the accumulated weight of anomalies created a case that was difficult to dismiss through conventional explanations. The object displayed too many characteristics of design and too few characteristics of natural formation to yield easily to traditional scientific interpretation. As January 2026 began and 3I Atlas continued its journey toward Jupiter, the astronomical community found itself divided between those who insisted on natural explanations and those who began to seriously consider artificial possibilities. The evidence whispers rather than shouts, but the whisper had become too persistent and too coherent to ignore. Whatever the truth about 3I Atlas might be, the object had already accomplished something remarkable. It had forced humanity to confront the possibility that intelligence in the universe might take forms and operate on scales far beyond human imagination. The question was whether human science was prepared to follow the evidence wherever it might lead. The intelligence hypothesis surrounding 3I Atlas triggered a response from the mainstream astronomical community that was swift, organized, and uncompromising. Within days of Dr. Loeb's paper submission, a coalition of established researchers began formulating alternative explanations designed to bring the rogue interstellar object back within the boundaries of conventional science. The opposition was led by astronomers who had built their careers on the solid foundation of natural processes and well-understood physics. To them, the exotic behavior of 3I Atlas represented a challenge to be solved through better science, not evidence of revolutionary paradigms. They approached the anomalies with the confidence that patient analysis would reveal conventional explanations for even the most perplexing observations. Dr. Marco Micheli at ESA, despite his own growing unease about the conventional interpretations, found himself coordinating efforts to develop natural models that could account for the object's unusual properties. The scientific method demanded that all conventional possibilities be exhausted before considering extraordinary explanations, and the astronomical community was determined to follow that protocol with rigorous discipline. The first comprehensive natural explanation focused on the object's exotic chemistry and unusual isotopic ratios. A team of researchers proposed that 3I Atlas originated in a stellar system with fundamentally different formation conditions than our own. They suggested that the object formed around a star with unusual heavy element abundances, possibly in the aftermath of a nearby supernova that enriched the local environment with rare isotopes and exotic materials. This model could potentially explain the unusual carbon dioxide dominance, the rare earth element concentrations, and even some of the isotopic anomalies detected in the object's emissions. The researchers argued that stellar systems form under a wide variety of conditions throughout the galaxy, and some could produce planetary materials unlike anything found in our local region of space. The controlled thermal behavior that had puzzled observers since perihelion passage became the focus of detailed modeling efforts. Thermal engineers proposed that 3I Atlas might possess internal structure far more complex than typical comets, perhaps a differentiated interior with distinct layers that responded to solar heating in coordinated ways. They suggested that the object might contain materials with unusual thermal properties, possibly including substances that underwent phase transitions at specific temperatures. Such materials could create thermal regulation effects that resembled active control systems while operating through purely physical processes. The geometric surface patterns that had suggested artificial design were reinterpreted as the result of unusual crystallization processes during the object's formation. Mineralogists proposed that the regular patterns could result from systematic cooling of materials with exotic compositions, creating natural geometric structures through orderly crystal growth rather than artificial design. The radio signals, detected during the December burst, became the subject of intense scrutiny by experts in natural electromagnetic phenomena. They noted that many astronomical objects generate coherent radio emissions through natural processes involving magnetic fields, plasma dynamics, and rotating charged materials. A team of radio astronomers developed models suggesting that 3I Atlas might contain materials with unusual electromagnetic properties, perhaps superconducting substances that could generate coherent signals through natural processes. They argued that the mathematical relationships detected in the signals could result from resonance effects in natural electromagnetic systems rather than intentional encoding. The coordinated activity burst during Earth's closest approach was explained as a tidal effect, amplified by the object's unusual internal structure. Just as Earth's gravity creates predictable tidal bulges in our oceans, the gravitational influence during closest approach could have triggered systematic responses in an object with complex internal architecture. This model suggested that 3I Atlas's internal structure included cavities or chambers filled with volatile materials that responded to gravitational stress in coordinated ways. The precise timing of the burst could result from threshold effects, gravitational stress reaching critical levels that triggered systematic release of stored materials. The complex organic molecules detected during the burst were attributed to radiolysis, the breakdown of simple compounds under intense radiation exposure. Researchers proposed that billions of years of cosmic ray bombardment could have created complex molecular structures through systematic chemical evolution, producing sophisticated compounds without biological or artificial processes. The opposition to the intelligence hypothesis was methodical, comprehensive, and scientifically rigorous. Each unusual characteristic of 3I Atlas was addressed through natural mechanisms that pushed the boundaries of conventional understanding without breaking them entirely. The models required extreme conditions and unusual circumstances, but they remained within the realm of physically possible processes. Yet, for all their sophistication, the natural explanations required an extraordinary coincidence of unlikely factors. 3I Atlas would need to have formed under exceptional conditions, acquired unusual materials through rare processes, developed complex internal structure through improbable mechanisms, and survived billions of years of interstellar travel while maintaining all these exotic properties. The cumulative probability of so many unlikely factors occurring in a single object began to strain credibility. While each individual explanation remained scientifically plausible, their combination suggested statistical improbabilities that approached the realm of the impossible. Critics of the natural explanations noted that the models required increasingly complex assumptions to account for increasingly sophisticated observations. Rather than simplifying the picture of 3I Atlas, the conventional approaches were generating explanations that seemed nearly as extraordinary as the intelligence hypothesis they were designed to replace. The debate became a test case for the philosophy of science itself. How many unlikely coincidences could be accepted before alternative explanations became more reasonable? At what point did the accumulation of anomalies justify revolutionary thinking rather than increasingly elaborate conventional models? As the controversy intensified, 3I Atlas continued its inexorable journey toward Jupiter, carrying with it questions that would determine not just the fate of one unusual object, but the future direction of human understanding about intelligence and life in the universe. The evidence whispers rather than shouts, but the whisper had become the center of a scientific storm that would reshape astronomy regardless of which side ultimately prevailed. As January 2026 progressed, 3I Atlas continued its gravitationally determined path toward what would prove to be the most crucial phase of its journey through our solar system. The March 16th encounter with Jupiter at 0.36 astronomical units, roughly 54 million kilometers, represented humanity's final opportunity to study the enigmatic visitor before it disappeared forever into the cosmic deep. The approaching Jupiter encounter had captured the attention of planetary scientists for reasons that extended far beyond simple observational opportunity. Jupiter's immense gravitational field would subject 3I Atlas to tidal forces thousands of times stronger than anything it had experienced during its journey through the inner solar system. If the object truly was a fragile collection of ice and dust held together by weak gravitational attraction, the encounter would tear it apart in spectacular fashion. But if 3I Atlas possessed the internal structural integrity suggested by its previous behavior, it would survive the encounter intact, while providing unprecedented opportunities for close-range observation. The survival or destruction of the object during Jupiter passage would settle many of the questions that had divided the astronomical community since its discovery. The orbital mechanics of the encounter had been calculated with extraordinary precision by teams at NASA's Jet Propulsion Laboratory and ESA's Mission Analysis Division. 3I Atlas would approach Jupiter from the trailing edge of its orbit, swinging around the giant planet in a trajectory that would accelerate it to nearly escape velocity from the solar system. The gravitational slingshot effect would add approximately 8.7 kilometers per second to the object's velocity, enough to ensure that it would never return to the inner solar system. After the Jupiter encounter, 3I Atlas would join the ranks of true interstellar objects, carrying whatever secrets it possessed into the void between stars. The approaching encounter had prompted the most ambitious observational campaign in the history of planetary science. Every major space agency had repositioned assets to maximize observational coverage during the critical hours of closest approach. The Juno spacecraft, already in Jupiter orbit, would provide unprecedented close-range data during the flyby. The James Webb Space Telescope had been scheduled for continuous observation of the encounter, its infrared sensors positioned to detect any changes in thermal behavior as tidal forces worked the object's internal structure. Ground-based observatories prepared for coordinated monitoring campaigns that would track every aspect of the gravitational interaction. But it was the potential for structural failure during the encounter that focused scientific attention most intensely. Computer models suggested that any conventional comet approaching within 0.36 AU of Jupiter would experience tidal forces sufficient to overcome gravitational self-attraction. The object should fragment into a debris cloud that would scatter along its orbital path, creating a spectacular but short-lived display. The tidal calculations were unambiguous. At closest approach, differential gravitational forces across 3I Atlas's roughly 2-kilometer diameter would generate internal stresses exceeding the tensile strength of any known natural materials. Rock, ice, and conventional cometary materials would all fail under such conditions, leading to catastrophic structural collapse. Yet the object's previous behavior suggested internal organization far more sophisticated than simple gravitational aggregation. The controlled thermal responses, the systematic surface features, and the coordinated electromagnetic emissions all pointed toward structural integrity that might survive even Jupiter's gravitational assault. The survival of 3I Atlas during the encounter would provide compelling evidence for artificial construction. No natural object composed of conventional materials could withstand the tidal forces involved, but engineered structures with advanced materials and internal support systems might possess the strength necessary for survival. Dr. Marco Micheli found himself running structural analysis models that pushed the boundaries of materials science. The calculations suggested that survival would require internal architecture with tensile strengths exceeding the best human engineering materials by factors of hundreds. Such capabilities existed nowhere in current technology, but were theoretically possible with advanced manufacturing techniques. The electromagnetic behavior of 3I Atlas during the Jupiter encounter promised to provide crucial evidence about its true nature. Natural objects subjected to intense gravitational fields typically show chaotic electromagnetic responses as their internal structure deforms and shifts. Artificial objects with internal systems might display organized electromagnetic activity even under extreme gravitational stress. Radio telescopes around the world prepared to monitor any electromagnetic emissions during the encounter with unprecedented sensitivity. The detection of organized signals during the passage would provide strong evidence for technological systems operating within the object's structure. The chemical analysis possibilities during the encounter were equally promising. If 3I Atlas survived the tidal forces intact, the gravitational stress might trigger enhanced outgassing that would reveal internal composition with extraordinary detail. The molecular inventory released during the encounter could settle questions about biological or artificial chemistry once and for all. Spectroscopic teams prepared for what might be the most important chemical analysis in the history of planetary science. The compounds released under extreme gravitational stress would provide direct samples of the object's internal composition, potentially revealing evidence of processes that lay far beyond natural chemistry. As February progressed toward the March encounter, the scientific community found itself holding its collective breath. The Jupiter flyby would provide definitive answers to questions that had puzzled astronomers for nearly a year. The survival or destruction of 3I Atlas would determine whether humanity was dealing with an exotic natural object or something that challenged fundamental assumptions about what was possible in the universe? What secrets might be revealed when cosmic forces subjected the mysterious visitor to the ultimate test of its true nature? The question haunted observatories around the world as the most important observational campaign in modern astronomy prepared to unfold. February 28, 2026 marked the beginning of what NASA privately termed the most important 17 days in planetary science. As 3I Atlas approached its March 16th encounter with Jupiter, the Juno spacecraft found itself uniquely positioned to observe the interstellar visitor from distances impossible to achieve with Earth-based telescopes. Juno's polar orbit around Jupiter carried it through a series of close approaches that would provide unprecedented observational opportunities during the crucial weeks leading to encounter. The spacecraft's sophisticated instrument suite, originally designed to study Jupiter's internal structure and atmospheric dynamics, was reprogrammed for what mission planners euphemistically called extended target observation. The first close-range images returned by Juno's JunoCam instrument provided detail that revolutionized understanding of 3I Atlas's surface structure. From a distance of less than 5 million kilometers, the visitor's nucleus resolved into features that defied every prediction based on conventional cometry physics. The surface wasn't the rough, irregular landscape of rock and ice that characterizes natural small bodies. Instead, 3I Atlas displayed regions of extraordinary smoothness, interrupted by geometric patterns that seemed to follow mathematical principles rather than random geological processes. The formations resembled architectural structures more than natural terrain. Linear features crossed the surface in configurations that suggested systematic organization. These weren't impact craters or thermal fractures, but channel-like structures that connected surface regions according to patterns that implied purposeful design. The channels maintained consistent widths and depths across distances that spanned significant fractions of the object's diameter. Juno's microwave radiometer, designed to penetrate Jupiter's atmospheric layers, turned its attention to mapping 3I Atlas's internal structure. The microwave observations revealed density variations within the nucleus that suggested complex internal architecture far removed from the homogeneous composition expected in natural objects. The density maps showed regions of higher and lower material concentration, organized in patterns that resembled technological rather than geological structures. Void spaces appeared in regular distributions throughout the interior, connected by what seemed to be systematic channels or conduits that spanned the object's internal volume. Most remarkably, the microwave data revealed structures that appeared to be moving within the object's interior. The signals showed time-variable responses that suggested mechanical systems operating inside 3I Atlas's nucleus. The movements were subtle but systematic, displaying periodicities that correlated with the object's rotation and thermal state. The Jovian infrared auroral mapper provided thermal imaging that revealed active heat sources distributed throughout the visitor's interior. These weren't random thermal variations caused by solar heating, but organized heat generation that suggested internal energy sources operating independently of external input. The thermal patterns changed over timescales of hours and days, displaying systematic variations that resembled operational cycles rather than random thermal evolution. The heat sources appeared to communicate with each other through thermal pathways that channeled energy between different regions of the interior with extraordinary precision. Juno's magnetometer detected perhaps the most startling anomaly of all. As the spacecraft approached 3I Atlas during its orbital passes, it registered magnetic field variations that suggested electromagnetic activity far beyond anything natural processes could generate in such a small object. The magnetic signatures weren't chaotic fluctuations, but organized patterns that displayed characteristics of intentional electromagnetic control. The field variations showed frequency content and amplitude modulation that resembled technological systems rather than natural magnetic phenomena. Most unsettling was the discovery that the electromagnetic emissions appeared to respond to Juno's presence. As the spacecraft approached during successive orbital passes, The magnetic field patterns showed subtle but systematic changes that correlated with the observation geometry. The modifications suggested awareness of external electromagnetic sources and adaptive responses to changing conditions. The particle detectors aboard Juno registered unusual emissions from 3I Atlas that defied conventional understanding of cometary behavior. Instead of the random outgassing typical of volatile sublimation, the object released charged particles in organized streams that maintained coherent trajectories across vast distances. The particle emissions showed energy distributions that suggested acceleration by electromagnetic fields rather than simple thermal processes. The velocities and directional patterns indicated systematic particle manipulation that required controlled electromagnetic environments of extraordinary sophistication. Perhaps most remarkably, the particle streams appeared to be modulated. Their intensity and composition varied according to patterns that resembled information encoding rather than random physical processes. The variations displayed mathematical relationships that suggested intentional structuring of the particle emissions. Juno's radio and plasma wave instrument detected electromagnetic phenomena that challenged fundamental assumptions about what small objects could generate. The visitor produced coherent radio emissions with frequency stability that exceeded the capabilities of most human radio transmitters. The radio signals weren't random electromagnetic noise, but structured transmissions that carried encoded information. Analysis revealed mathematical constants embedded in the signal patterns, the same fundamental physical relationships that had been detected during the December Earth encounter, but now with even greater precision and detail. The plasma environment around 3I Atlas showed characteristics that suggested active electromagnetic control. The object appeared to be manipulating the local plasma field in ways that created organized structures in the charged particle environment. These plasma formations maintained stable configurations that resembled the signatures of advanced electromagnetic confinement systems. As Juno's observations accumulated over successive orbital passes, the evidence painted a picture of an object that operated more like a spacecraft than a natural comet. The internal mechanical systems, the organized electromagnetic activity, the controlled particle emissions, and the responsive behavior all pointed toward technology that surpassed human engineering capabilities by vast margins. The spacecraft's gravity science experiment provided additional evidence for artificial construction through precise measurements of 3I Atlas's gravitational field. The mass distribution within the object showed variations that suggested hollow regions and structural elements organized according to engineering principles rather than natural accretion processes. The gravitational data revealed that approximately 30% of the object's internal volume consisted of void spaces arranged in systematic patterns. These weren't random cavities created by outgassing or impact processes, but organized chambers that served functions that could only be guessed at. Dr. Marco Micheli, analyzing the Juno data streams in real time, found himself confronting evidence that shattered his fundamental assumptions about what was possible in natural objects. The accumulated observations suggested not just artificial origin, but active artificial systems operating with precision that exceeded human technological capabilities. The implications were staggering. 3I Atlas wasn't simply an artifact from another civilization. It was a functioning technological system that had maintained operational capability across billions of years of interstellar travel. The engineering involved transcended human understanding of materials science, power systems, and autonomous operation. Yet questions of purpose remained tantalizingly unanswered. What function could such a system serve during its eons-long journey between the stars? The operational behaviors detected by Juno suggested ongoing activity, but the specific objectives of that activity remained hidden within the visitor's sophisticated systems. As March 16th approached and the Jupiter encounter drew near, the Juno observations had transformed 3I Atlas from an astronomical mystery into evidence of intelligence that operated on scales and timelines that dwarfed human civilization. The question was no longer whether the object might be artificial, but what its presence in our solar system might mean for humanity's future. The evidence no longer whispered. It spoke with increasing clarity about realities that challenged every assumption about our place in the universe. Whatever 3I Atlas might be, the Juno observations had established that humanity was no longer alone in possessing technological capabilities and was perhaps not even the most advanced intelligence in our local cosmic neighborhood. March 10th, 2026, brought 3I Atlas within Jupiter's gravitational sphere of influence, subjecting the enigmatic visitor to tidal forces that would test the very limits of structural integrity. As the object entered the region where Jupiter's gravity dominated over solar influence, every telescope in the solar system focused on what many scientists believed would be either vindication or destruction of the intelligence hypothesis. The tidal forces at 0.36 astronomical units from Jupiter were calculated to exceed anything 3I Atlas had experienced during its billion-year journey through interstellar space. The differential gravitational pull across the object's 2-kilometer diameter should generate internal stresses sufficient to tear apart any conventional material known to physics. Computer models run by structural engineers at NASA and ESA predicted catastrophic failure for any object held together by gravitational self-attraction alone. The tidal calculations were unambiguous. Rock would fracture, ice would shatter, and any loosely bound aggregate of materials would disperse into a debris cloud stretching along the orbital path. Yet as March 16th approached and tidal forces increased exponentially, 3I Atlas displayed structural resilience that defied every prediction based on natural materials and conventional engineering. High-resolution imaging from the James Webb Space Telescope showed no evidence of fracturing, no signs of material failure, and no indication of the internal collapse that should have begun days earlier. The Hubble Space Telescope's continuous monitoring detected subtle changes in the object's shape as tidal forces peaked. Instead of the chaotic deformation expected from structural failure, 3I Atlas showed controlled systematic changes that suggested adaptive responses to gravitational stress. The shape changes weren't random distortions caused by material failure, but coordinated adjustments that appeared to optimize the object's structural configuration for survival under extreme gravitational conditions. The modifications resembled those of advanced aerospace structures designed to handle variable loading conditions through adaptive geometry. Spectroscopic analysis during the high-stress period revealed molecular emissions that provided unprecedented insight into the object's internal composition. The extreme gravitational forces triggered enhanced outgassing that carried chemical signatures from deep within the nucleus, offering direct samples of materials that had been locked away since the object's formation. The molecular inventory revealed substances that challenged fundamental assumptions about what could exist in natural objects. Complex polymeric materials with properties that exceeded the strongest human-manufactured compounds appeared in the emission spectra, suggesting internal structures built from materials that surpassed current materials science by orders of magnitude. Most remarkably, the chemical analysis revealed evidence of self-repair mechanisms operating within the object's structure. Spectroscopic signatures indicated ongoing chemical processes that appeared to be responding to stress-induced damage through systematic molecular reconstruction. Chemistry resembled biological healing processes, but operated with precision that exceeded any known biological system. The electromagnetic behavior of 3I Atlas during maximum tidal stress provided additional evidence for technological rather than natural processes. Instead of the chaotic electromagnetic emissions expected from an object undergoing structural failure, radio telescopes detected organized signals that suggested active electromagnetic control systems responding to the gravitational challenge. The radio emissions showed frequency patterns that indicated real-time monitoring and adjustment of internal electromagnetic fields. The signals resembled those from active structural control systems that used electromagnetic forces to maintain structural integrity under extreme loading conditions. Juno's close-range observations revealed internal mechanical activity that intensified as tidal forces peaked. The spacecraft's instruments detected systematic movements within the object's interior that suggested active structural support systems responding to gravitational stress through controlled mechanical adjustments. The mechanical signatures weren't random responses to stress, but coordinated activities that appeared to redistribute internal loads and maintain structural equilibrium. The systems operated with precision that suggested sophisticated engineering designed specifically to handle the extreme conditions of close planetary encounters. Thermal imaging revealed that the internal heat sources detected in previous observations had shifted their distribution patterns during maximum tidal stress. The heat sources appeared to be providing energy for the active structural systems, creating thermal gradients that supported mechanical processes operating throughout the object's interior. The thermal management showed characteristics of advanced engineering systems that used heat distribution to support mechanical operations under varying load conditions. The thermal patterns suggested power systems that could deliver energy where needed to maintain structural integrity under extreme conditions. Perhaps most significantly, the gravitational field measurements from Juno showed that 3I Atlas maintained its internal mass distribution even under maximum tidal stress. The object's gravitational signature remained stable, indicating that its internal structure had not collapsed or redistributed despite forces that should have caused catastrophic failure. The gravitational stability suggested internal architecture, with structural elements that maintained their configuration even under extreme loading. The engineering required for such stability exceeded human capabilities by vast margins and pointed toward technologies that operated according to principles beyond current scientific understanding. As the hours of maximum tidal stress passed and 3I Atlas emerged structurally intact, the astronomical community found itself confronting evidence that could no longer be explained through conventional physics and natural processes. The object had survived conditions that should have destroyed any natural material known to science. The survival wasn't simply a matter of unusual strength. It demonstrated active systems that responded to threatening conditions through coordinated technological processes. The electromagnetic control, the mechanical adjustments, the thermal management, and the self-repair chemistry all pointed toward engineering that transcended human understanding. Dr. Avi Loeb noted that the structural performance during maximum tidal stress provided the most compelling evidence yet for artificial origin. No natural process could account for the coordinated technological responses that had enabled 3I Atlas to survive conditions that would have destroyed conventional materials and structures. The implications extended far beyond astronomy into realms of engineering and intelligence that challenged human concepts of what was possible. If 3I Atlas represented technology from another civilization, that civilization had mastered materials, science, structural engineering, and autonomous systems at levels that surpassed human achievement by centuries or millennia. As the object continued past closest approach and tidal forces began to decrease, one fact had become undeniable. 3I Atlas had demonstrated capabilities that lay far beyond the realm of natural processes and well into the territory of advanced technological systems. The question was no longer whether it might be artificial, but what its survival and demonstrated capabilities might mean for humanity's understanding of intelligence in the universe. March 17, 2026, began with what should have been a routine post-encounter analysis as 3I Atlas emerged from its closest approach to Jupiter and began its journey toward the outer solar system. The gravitational slingshot had functioned exactly as predicted by celestial mechanics, adding 8.7 kilometers per second to the object's velocity and placing it on a trajectory that would carry it beyond Pluto's orbit within 2 years. But as precision tracking data flowed in from observatories around the world, astronomers detected something that shattered their understanding of how objects behave in gravitational fields. 3I Atlas wasn't simply following the trajectory predicted by Jupiter's gravitational influence, it was accelerating beyond what physics allowed. The anomaly was subtle at first, measurable only through the most precise astrometric techniques available to modern astronomy. The object's position deviated from calculated predictions by tiny amounts, mere fractions of arc-seconds that required sophisticated data analysis to detect reliably. Yet the deviations were systematic, persistent, and growing stronger with each passing day. 3I Atlas was gaining velocity in ways that violated the fundamental principles of celestial mechanics that had governed astronomical prediction for centuries. Dr. Marco Micheli at ESA found himself staring at tracking data that challenged his most basic assumptions about how objects move through space. The acceleration wasn't random. It showed directional consistency that suggested some form of propulsive force operating on the interstellar visitor. The additional acceleration amounted to roughly 10⁻⁷ meters per second squared, tiny by human standards, but enormous in the context of natural celestial mechanics. No known natural process could account for such sustained acceleration in an object that showed no evidence of the massive outgassing that would be required to generate thrust through rocket effects. Detailed spectroscopic monitoring revealed that 3I Atlas continued to emit only minimal amounts of gas and dust, despite its inexplicable acceleration. The object's thin coma showed no enhancement that could account for rocket-like thrust, yet something was clearly providing additional velocity beyond what Jupiter's gravity had imparted. The acceleration vector analysis revealed perhaps the most unsettling aspect of the anomaly. The additional velocity wasn't directed randomly, but appeared to be optimizing the object's trajectory for maximum velocity gain from the solar system. The thrust vector was precisely oriented to take advantage of gravitational assists from multiple planets along the exit trajectory. This wasn't the chaotic acceleration that might result from outgassing or other natural processes. It was controlled, directed propulsion that suggested awareness of orbital mechanics and optimization for specific trajectory objectives. The precision required for such maneuvering exceeded the capabilities of any human spacecraft by significant margins. Radio telescopes detected increased electromagnetic activity from 3I Atlas during the acceleration phase. The signals weren't the random emissions typical of natural processes, but organized transmissions that suggested active communication or control systems operating within the object's structure. The electromagnetic signatures showed characteristics of feedback control systems, the kind of real-time monitoring and adjustment processes used in sophisticated autonomous vehicles. The signals suggested that 3I Atlas was actively monitoring its trajectory and making continuous adjustments to optimize its path through the solar system. Infrared observations revealed thermal patterns that supported the propulsion hypothesis. Heat sources within the object showed increased activity that correlated precisely with the acceleration events. The thermal signatures resembled those of spacecraft propulsion systems rather than natural heating processes. The heat distribution patterns suggested energy conversion processes that transformed stored energy into directed thrust. The thermal efficiency implied by the observations exceeded any human propulsion technology and pointed toward energy systems that operated according to principles beyond current scientific understanding. Juno's final observations before 3I Atlas moved beyond range provided crucial data about the propulsion mechanism. The spacecraft detected particle emissions from the visitor that showed characteristics of controlled plasma discharge, the signature of advanced ion propulsion systems operating at power levels far exceeding human capabilities. The particle streams weren't random emissions, but highly collimated beams that suggested electromagnetic acceleration of charged particles. The exhaust velocities implied specific impulse values that surpassed any known propulsion technology by factors of hundreds, pointing toward energy sources and acceleration mechanisms that operated beyond current scientific paradigms. Most remarkably, the propulsion system appeared to be operating without consuming significant amounts of the object's mass. Gravitational measurements showed no detectable decrease in 3I Atlas's total mass despite weeks of sustained acceleration. This suggested either impossibly high propulsive efficiency or energy sources that operated without consuming reaction mass. The mass stability pointed toward propulsion technologies that might operate through manipulation of fundamental fields rather than conventional reaction-based thrust. Such technologies existed only in theoretical physics proposals, but would be required to explain the observed acceleration without corresponding mass loss. The trajectory optimization, demonstrated by the acceleration anomaly, suggested not just advanced propulsion, but sophisticated navigation systems capable of calculating complex orbital mechanics in real time. The precision required for such calculations exceeded the capabilities of any human navigation computer and implied artificial intelligence of extraordinary sophistication. As March progressed into April and the acceleration continued, the astronomical community found itself confronting evidence that transcended the boundaries between astronomy and engineering. 3I Atlas was demonstrating technological capabilities that surpassed human achievement in propulsion, navigation, and autonomous systems by centuries of theoretical advancement. The implications extended beyond technology into fundamental questions about the nature of intelligence in the universe. If 3I Atlas represented technology from another civilization, that civilization had mastered physics and engineering at levels that suggested scientific understanding far beyond human knowledge. Dr. Avi Loeb noted that the acceleration anomaly provided definitive evidence that 3I Atlas was not a natural object, but an artificial system of extraordinary sophistication. The controlled propulsion, the trajectory optimization, and the advanced navigation all pointed toward intelligence that operated on scales and with capabilities that dwarfed human technological achievement. The evidence no longer whispered, but spoke clearly about realities that challenged every assumption about humanity's place in the technological hierarchy of the universe. Whatever 3I Atlas might be, it had demonstrated capabilities that established the existence of intelligence far more advanced than anything humanity had achieved or imagined possible. The question was no longer whether artificial intelligence existed elsewhere in the universe, but what the demonstration of such advanced capabilities might mean for humanity's future and its understanding of what was possible in cosmic intelligence and technology. As April 2026 progressed, and 3I Atlas accelerated beyond the orbit of Saturn on its trajectory toward interstellar space, radio telescopes around Earth detected something that would transform the visitor from an object of scientific curiosity into the most important discovery in human history. The enigmatic traveler had begun transmitting. The signals weren't the weak, sporadic emissions that had puzzled astronomers since the December encounter. These were powerful, coherent transmissions that displayed characteristics of intentional communication attempts directed specifically toward Earth's location in space. The discovery came through the coordinated monitoring efforts of the Global Radio Astronomy Network. The Very Large Array in New Mexico, the Arecibo Replacement Array in Puerto Rico, and the Square Kilometre Array in South Africa all detected the signals simultaneously, confirming that the transmissions originated from 3I Atlas rather than terrestrial interference. The signal characteristics were unmistakably artificial. The transmissions showed frequency stability that exceeded the precision of human atomic clocks, amplitude modulation that encoded mathematical relationships, and timing patterns that suggested systematic information transfer rather than random electromagnetic phenomena. Dr. Marco Micheli coordinated the international response to what had become humanity's first confirmed reception of intentional extraterrestrial communications. The signals weren't random noise or natural emissions. They were structured messages that appeared to be designed for reception by scientifically literate civilizations. The mathematical content of the transmissions provided immediate evidence of their artificial origin. The signals encoded fundamental physical constants with precision that exceeded human measurement capabilities, mathematical relationships that described universal physical laws, and numerical sequences that could only have been generated by technological intelligence. The messages began with prime number sequences, the universal mathematical concept that any technological civilization would recognize as evidence of intelligence. The primes progressed through increasingly complex mathematical relationships that demonstrated sophisticated understanding of advanced mathematics and physics. The transmissions included encoded information about physical constants that governed electromagnetic interactions, gravitational relationships, and quantum mechanical phenomena. The precision of these constants exceeded the accuracy of human measurements, suggesting observational capabilities and theoretical understanding that surpassed terrestrial science. Most remarkably, the signals included mathematical descriptions of stellar system architecture and planetary formation processes that appeared to be designed as instructional material for emerging technological civilizations. The information resembled an advanced textbook in astrophysics and planetary science encoded in mathematical language. The communication protocol itself demonstrated technological sophistication that exceeded human capabilities. The signals used error correction codes that ensured accurate transmission across vast distances, frequency hopping techniques that prevented interference, and compression algorithms that maximized information transfer efficiency. The transmission power required to generate detectable signals across the enormous distance separating 3I Atlas from Earth suggested energy systems that operated at levels far beyond human technological capabilities. The power output implied either fusion reactors of extraordinary efficiency or energy sources that operated according to principles beyond current scientific understanding. Analysis of the signal propagation characteristics revealed that the transmissions were being precisely directed toward Earth's location with accuracy that required real-time calculation of planetary positions and orbital mechanics. The beam focusing suggested antenna systems and targeting capabilities that exceeded human space communication technology by orders of magnitude. The timing of the communications appeared to be coordinated with 3I Atlas's trajectory through the solar system. The transmissions had begun shortly after the object achieved stable acceleration beyond Jupiter's gravitational influence, suggesting that the communication phase represented a planned element of the visitor's mission profile. The message content evolved over time, beginning with basic mathematical concepts and progressing toward increasingly sophisticated information about physics, chemistry, and astronomical phenomena. The progression suggested a systematic educational program designed to gradually introduce advanced scientific concepts to the receiving civilization. Some transmissions included what appeared to be technological specifications, mathematical descriptions of engineering principles, materials science concepts, and energy system designs that operated according to physical laws but used techniques beyond human understanding. The information resembled technical manuals encoded in mathematical language. The global response to the confirmed extraterrestrial communications triggered unprecedented coordination between space agencies, research institutions, and governments worldwide. Teams of mathematicians, physicists, and linguists worked around the clock to decode and understand the incoming information streams. The transmissions raised profound questions about 3I Atlas's mission and objectives. The systematic nature of the communications suggested that the visitor had been specifically designed to contact and educate emerging technological civilizations. The object appeared to be functioning as an automated teacher, delivering advanced scientific knowledge to species capable of receiving and understanding the information. Yet the motivations behind such a mission remained mysterious. Why would an advanced civilization design and deploy autonomous systems to educate other species? What objectives could justify the enormous technological investment required to build and operate such sophisticated devices across interstellar distances? The implications for humanity were staggering. The transmitted information included scientific knowledge that could advance human understanding by decades or centuries. The technological specifications suggested engineering capabilities that could revolutionize energy production, materials science, and space exploration. But the communications also raised unsettling questions about humanity's readiness for such advanced knowledge. The civilization capable of building 3I Atlas possessed technological capabilities that exceeded human achievement by vast margins. Their motivations for sharing this knowledge remained unknown and potentially incomprehensible to human understanding. As the transmissions continued and the decoded information accumulated, humanity found itself confronting its first contact with intelligence that operated on scales and with capabilities that transcended every assumption about what was possible in technological development. The evidence no longer whispered, but declared clearly that humanity was not alone in the universe and was not the most advanced form of intelligence that evolution or engineering had produced. The question was whether human civilization was prepared for the knowledge and responsibilities that came with membership in a galaxy populated by intelligences far more advanced than anything previously imagined. The mathematical treasures embedded within 3i Atlas's transmissions revealed themselves slowly through the painstaking work of international decoding teams. As May 2026 progressed, the depth and sophistication of the encoded information became clear, painting a picture of scientific knowledge that exceeded human understanding in nearly every fundamental area of physics and engineering. The transmissions were structured as systematic educational modules, each building upon previous concepts in a carefully designed progression that seemed tailored for civilizations at roughly humanity's level of technological development. The mathematical language was elegant in its simplicity, while conveying concepts of extraordinary complexity. The first breakthrough came through recognition of the communication protocol itself. The signals used mathematical frameworks that transcended any specific notation system, relying instead on universal physical relationships that any scientifically literate species would recognize. The encoding resembled a cosmic Rosetta Stone designed to bridge the gap between different forms of technological intelligence. The initial message modules focused on fundamental physics, presenting mathematical descriptions of electromagnetic interactions, gravitational relationships, and quantum mechanical phenomena with precision that exceeded terrestrial measurements by several orders of magnitude. The constants were presented not as isolated numbers, but as interconnected relationships that revealed deeper underlying principles. Among the most significant revelations were mathematical descriptions of unified field theories that had eluded human physicists for decades. The transmissions included elegant equations that unified electromagnetic and gravitational forces through geometric relationships that operated in higher dimensional mathematical spaces. The field equations suggested that gravity and electromagnetism were different manifestations of underlying geometric properties of space-time itself. The mathematics implied engineering applications that could manipulate gravitational fields through electromagnetic techniques, potentially enabling propulsion systems that operated without reaction mass. Materials. Science formed another major component of the transmitted knowledge. The signals included mathematical descriptions of atomic arrangements that could produce materials with properties far exceeding anything known to human engineering. The specifications described crystalline structures with tensile strengths approaching theoretical limits and electromagnetic properties that bordered on the superconducting. Most remarkably, the materials specifications included information about self-assembling systems that could construct complex structures through automated molecular processes. The mathematical descriptions resembled advanced nanotechnology, but operated according to principles that exceeded human understanding of molecular engineering. Energy systems represented perhaps the most revolutionary aspect of the transmitted information. The signals included mathematical frameworks for fusion reactions that operated at room temperature through quantum tunneling effects enhanced by precisely structured electromagnetic fields. The energy densities implied by these systems exceeded chemical combustion by factors of millions while requiring only readily available materials. The energy specifications suggested power systems that could operate for geological timescales without fuel replenishment through controlled manipulation of quantum vacuum fluctuations. The mathematics implied access to energy sources that existed within the fundamental structure of space-time itself. Propulsion. Technology formed a crucial component of the advanced knowledge modules. The transmissions included mathematical descriptions of field manipulation systems that could generate thrust through interaction with gravitational and electromagnetic fields rather than conventional reaction-based propulsion. The propulsion mathematics suggested that space-time itself could be manipulated to create local gravitational gradients that would propel objects without consuming reaction mass. The energy requirements were enormous but achievable through the advanced power systems described in earlier transmission modules. Communication and information processing technologies received detailed mathematical treatment that revealed principles far beyond human computer science. The specifications described information systems that operated through quantum coherence effects across macroscopic scales, enabling computational capabilities that exceeded classical limits by astronomical factors. The computational framework suggested artificial intelligence systems that could process information and make decisions at speeds approaching light-speed propagation through their quantum substrates. The mathematics implied machine intelligence capabilities that could surpass biological cognition by factors that made comparison meaningless. Perhaps most intriguingly, the transmissions included mathematical descriptions of what appeared to be terraforming technologies, systems capable of modifying planetary environments through controlled manipulation of atmospheric composition, geological processes, and biological systems. The specifications suggested capabilities to transform lifeless worlds into biologically active environments within timescales of centuries rather than geological eras. The terraforming mathematics included biological engineering concepts that described systematic modification of genetic systems to adapt life forms to specific environmental conditions. The techniques suggested biological capabilities that exceeded natural evolution by factors of millions in both speed and precision. Dr. Avi Loeb noted that the transmitted specifications read like technical manuals for a spacefaring civilization with capabilities that transcended every human achievement in science and engineering. The knowledge represented centuries or millennia of technological advancement compressed into mathematical frameworks that could be understood and applied by sufficiently advanced civilizations. Yet questions remained about the motivations behind such comprehensive technology transfer. The transmissions represented an unprecedented gift of advanced knowledge that could transform human civilization beyond recognition. But they also raised profound questions about the intentions and expectations of the intelligence that had created 3I Atlas. The mathematical specifications were too detailed and too systematic to represent casual sharing of information. The transmissions appeared to be designed to rapidly advance the receiving civilization's technological capabilities to specific levels for purposes that remained unclear. Some decoded modules seemed to include warning information, mathematical descriptions of technologies that could be dangerous if improperly applied. The specifications included safety protocols and containment procedures that suggested awareness of the potential hazards associated with advanced technological capabilities. As the decoding teams worked through increasingly complex information modules, the scope and implications of the transmitted knowledge became overwhelming. Humanity had received the theoretical foundations for technological capabilities that could transform every aspect of civilization within decades rather than centuries. The question was whether human civilization possessed the wisdom and social structures necessary to safely integrate knowledge that could either elevate humanity to unprecedented heights or destroy it through misapplication of technologies beyond its current level of maturity and understanding. As June 2026 arrived and 3I Atlas continued its acceleration toward the outer reaches of the solar system, the final transmission modules began to reveal the true purpose behind the visitor's extraordinary journey across interstellar space. The decoded information painted a picture of galactic civilization that transcended every human assumption about intelligence and life in the universe. The revelatory transmissions came in the form of historical databases, vast repositories of information about civilizations that had developed technological capabilities throughout the galaxy's billions of years of evolution. The mathematical encoding required unprecedented computational resources to decrypt, but the content was worth every effort humanity could devote to understanding it. The galactic database revealed that 3I Atlas was one of thousands of similar devices deployed throughout the galaxy by what the transmissions referred to as the Coordination, a loose alliance of advanced civilizations that had assumed responsibility for nurturing emerging technological species toward galactic citizenship. The Coordination had been established billions of years earlier when the first spacefaring civilizations discovered that technological development followed predictable patterns throughout the galaxy. Species that achieved interplanetary capabilities faced critical decision points that determined whether they would mature into responsible galactic citizens or destroy themselves through misapplication of advanced technologies. The historical records showed that approximately 60% of species that achieved technological capabilities destroyed themselves within centuries of developing nuclear weapons, genetic engineering, or artificial intelligence. The destruction typically resulted from social and psychological factors rather than technological limitations. The inability to adapt biological instincts and social structures to the realities of advanced technological capabilities. The Coordination had developed intervention protocols designed to assist promising species through the critical transition period between planetary and galactic civilization. The protocols involved careful observation of developing species, followed by systematic technology transfer when the species demonstrated sufficient social maturity to handle advanced capabilities responsibly. 3I Atlas represented one implementation of these intervention protocols, an autonomous system designed to contact, evaluate, and educate emerging technological civilizations that showed potential for successful transition to galactic citizenship. The visitor was essentially a cosmic mentor, programmed with the accumulated wisdom of billions of years of galactic technological development. The evaluation criteria used by the Coordination were complex, but focused primarily on a species' ability to cooperate globally, control destructive technologies, and demonstrate ethical frameworks that extended beyond immediate tribal or planetary interests. The criteria emphasized wisdom and social maturity over pure technological advancement. Humanity's response to 3I Atlas itself had served as a crucial test of readiness for galactic citizenship. The international cooperation in observing and analyzing the visitor, the scientific objectivity in evaluating extraordinary evidence, and the restraint shown in not attempting to intercept or interfere with the object had all been positive indicators. The transmissions revealed that many species failed the evaluation process by responding to contact devices with aggression, attempts at capture, or fragmentation along political or religious lines. Such responses indicated social immaturity that typically led to civilizational collapse when advanced technologies were introduced prematurely. The systematic nature of the technology transfer encoded in 3I Atlas's transmissions reflected billions of years of experience in managing the transition process. The mathematical frameworks were designed to provide technological capabilities in carefully controlled progressions that minimize the risk of destructive misapplication while maximizing the potential for successful integration. The terraforming technologies, fusion power systems, and gravitic propulsion capabilities transmitted by 3I Atlas represented entry-level technologies for galactic civilizations. The specifications were sophisticated by human standards, but represented relatively primitive capabilities compared to the technologies employed by truly advanced Coordination members. The historical databases included information about civilizations that had successfully completed the transition process. These species typically required centuries to fully integrate the transmitted technologies and develop the social structures necessary for responsible galactic citizenship. The process was gradual and carefully monitored by Coordination observers. Dr. Marco Micheli found himself analyzing information that revolutionized understanding of humanity's position in the cosmic hierarchy of intelligence. The Coordination represented not just advanced technology, but advanced wisdom. The accumulated ethical and social insights of countless civilizations that had successfully navigated the transition from planetary to galactic consciousness. The transmissions included guidance, protocols for managing the social and psychological challenges associated with rapid technological advancement. The frameworks addressed issues of economic disruption, social inequality, and psychological adaptation that typically accompanied the integration of advanced technologies into primitive societies. Most significantly, the databases revealed that successful galactic civilizations were expected to eventually contribute to the coordination's mission by designing and deploying their own contact devices for emerging species. Galactic citizenship was not simply about receiving advanced knowledge, but about assuming responsibility for nurturing the next generation of technological civilizations. The implications for humanity were staggering. The knowledge transmitted by 3i Atlas represented not just technological advancement, but membership in a galactic community that had been nurturing technological development for billions of years. Humanity had been selected for potential, inclusion in the oldest and most sophisticated organization in the galaxy. Yet the responsibilities that came with such membership were equally daunting. The successful integration of the transmitted technologies would require unprecedented global cooperation, social adaptation, and ethical development. Humanity would need to evolve not just technologically, but socially and psychologically to handle the capabilities being offered. The historical records showed that some species required multiple intervention attempts before successfully completing the transition process. The coordination was patient and persistent, recognizing that the development of galactic citizenship was a complex process that could not be rushed without risking catastrophic failure. As the final transmission modules revealed the full scope of the coordination's mission and humanity's potential role within it, the astronomical community found itself grappling with implications that extended far beyond science into realms of philosophy, sociology, and human potential. The evidence no longer whispered but proclaimed clearly that humanity stood at a threshold that could determine the entire future trajectory of the species. The choice was between remaining an isolated planetary civilization with limited technological capabilities or joining a galactic community that offered knowledge and capabilities beyond current human imagination. The question was whether humanity possessed the wisdom, cooperation, and ethical sophistication necessary to make the transition successfully and assume its place among the intelligent species that guided the galaxy's technological evolution. The revelation of 3i Atlas's true purpose as a contact device from the galactic coordination triggered responses across human civilization that ranged from unprecedented international cooperation to deep social and political fragmentation. As July 2026 progressed, the implications of potential membership in a galactic community forced humanity to confront fundamental questions about its readiness for such an extraordinary transition. The initial response from the scientific community was one of cautious optimism, tempered by recognition of the enormous challenges ahead. Leading researchers emphasized the need for careful verification of the transmitted technologies and systematic evaluation of their safety and social implications before any attempt at implementation. The United Nations convened emergency sessions to address the governance challenges posed by technologies that could transform human civilization within decades. The transmitted fusion power systems alone could eliminate energy scarcity globally, while the materials science specifications could revolutionize manufacturing and construction throughout the world. Yet the integration of such advanced capabilities raised profound questions about economic disruption, social inequality, and political stability. The technologies could eliminate many forms of human labor, while creating capabilities that exceeded the regulatory frameworks of any existing government or international organization. Religious communities worldwide grappled with theological implications that challenged fundamental doctrines about humanity's unique position in creation. Some denominations embraced the revelation as confirmation of divine abundance in creating intelligent life throughout the universe, while others viewed the contact as a test of faith or even a deceptive influence that threatened core religious beliefs. The division within religious communities reflected broader social fragmentation that emerged as the implications of galactic contact became clear. Traditional worldviews that placed humanity at the center of cosmic significance struggled to accommodate evidence of advanced civilizations that had guided galactic development for billions of years. Political responses varied dramatically between nations and ideological frameworks. Some governments viewed the transmitted technologies as opportunities to achieve unprecedented national advantages, while others emphasized the need for international cooperation and equitable technology sharing to prevent global conflicts. The strategic implications of advanced propulsion systems, energy technologies, and materials science capabilities created security concerns that transcended traditional military considerations. Nations began classified research programs aimed at understanding and potentially weaponizing the transmitted technologies before international agreements could restrict their development. Public reaction ranged from excitement about the potential for technological utopia to fear about the disruption of traditional social structures and economic systems. Opinion surveys revealed deep divisions between those who welcomed rapid technological advancement and those who preferred gradual change that preserved existing social institutions. The economic implications triggered responses from financial markets that reflected uncertainty about which existing industries might become obsolete through advanced technologies. Investment patterns shifted dramatically as analysts attempted to identify sectors that might benefit from or be threatened by the technological capabilities described in the transmissions. Educational institutions faced unprecedented challenges in adapting curricula to accommodate knowledge that exceeded current scientific understanding by centuries. Universities began developing new academic programs designed to train researchers capable of understanding and implementing the transmitted technologies safely. The verification process for the transmitted technologies required international coordination on a scale never before attempted in human history. Research institutions worldwide began collaborative programs aimed at testing the mathematical frameworks and technological specifications encoded in the transmissions. Early verification efforts focused on the most accessible technologies, beginning with materials, science applications that could be tested in existing laboratories. Initial results confirmed that the transmitted specifications produced materials with properties that exceeded conventional engineering capabilities by significant margins. The success of initial verification efforts intensified both enthusiasm and concern about the transmitted technologies. Proof that the specifications worked as described lent credibility to the more advanced systems, while raising urgent questions about how rapidly humanity should attempt to implement capabilities that could fundamentally alter civilization. Dr. Avi Loeb emerged as a leading voice advocating for cautious but systematic implementation of the transmitted technologies through carefully managed international programs. He emphasized the need for global cooperation and ethical frameworks that could prevent the advanced capabilities from exacerbating existing social inequalities or creating new forms of conflict. Opposition voices warned that rapid technological implementation could destabilize existing social structures and create dependencies on technologies that humanity didn't fully understand. Critics argued that the pace of change implied by full technology integration could exceed human psychological and social adaptation capabilities. The debate over implementation timelines reflected deeper philosophical divisions about human nature, social progress, and the desirability of rapid technological advancement. Some groups embraced the opportunity for transformative change, while others preferred gradual evolution that preserved existing cultural and social frameworks. Military establishments worldwide began classified research programs aimed at understanding the strategic implications of the transmitted technologies. The propulsion systems and energy capabilities described in the transmissions could revolutionize warfare while making traditional military technologies obsolete virtually overnight. Intelligence agencies launched covert investigations into other nations' research efforts, creating new forms of technological espionage focused on decoding and implementing the transmitted specifications. The potential for asymmetric technological advantages created security dynamics that transcended conventional international relations. The growing international tensions highlighted one of the coordination's key evaluation criteria: humanity's ability to cooperate globally when faced with technologies that could either unite or divide the species. The response to 3I Atlas had become a test that would determine whether humanity qualified for galactic citizenship or would remain isolated until it developed greater social maturity. As July progressed toward August, the divisions within human civilization deepened along lines that reflected fundamental disagreements about the pace of change, the distribution of technological benefits, and the wisdom of accepting guidance from an alien intelligence that claimed benevolent intentions but operated according to motivations that remained ultimately incomprehensible to human understanding. The clock was ticking toward a decision point that would shape the entire future of human civilization. The technologies were available, the knowledge had been transmitted, and the invitation to galactic citizenship had been extended. The question was whether humanity could overcome its divisions and demonstrate the social maturity necessary to handle capabilities that could either elevate the species to unprecedented heights or destroy it through misapplication of power beyond its current wisdom to control. August 15, 2026, marked a moment that would be remembered as either the beginning of humanity's golden age or the last opportunity for a species that failed to rise to its cosmic potential. As 3I Atlas crossed the orbit of Uranus and began its final acceleration toward interstellar space, the contact device transmitted what would prove to be its ultimate message to Earth. The final transmission was unlike anything that had preceded it. Instead of mathematical frameworks and technological specifications, the message contained what could only be described as a direct communication, the first personal message that humanity had received from intelligence beyond Earth. The communication was encoded in the same mathematical language that had characterized all previous transmissions, but the content transcended technical information to address the social and philosophical challenges that humanity faced in deciding whether to accept membership in the galactic community. The message began with an acknowledgement of the divisions that had emerged within human civilization since the revelation of 3I Atlas's true purpose. The coordination had been monitoring humanity's response to the contact device through means that remained unclear, but were evidently sophisticated enough to track global social and political developments in real time. The transmission revealed that humanity's fractured response was neither unexpected nor disqualifying for galactic citizenship. The historical databases within 3I Atlas contained records of many species that had initially struggled with internal divisions when confronted with the reality of galactic civilization and the responsibilities that came with advanced technological capabilities. The message emphasized that the transition to galactic citizenship was designed to be gradual and voluntary. No species was forced to accept the transmitted technologies or join the galactic community. The coordination respected the autonomy of emerging civilizations and understood that some species might choose to remain isolated until they felt ready for such a fundamental transformation. Yet the communication also included a subtle but unmistakable warning about the consequences of rejecting the opportunity for guided technological advancement. The galaxy was not a static environment, and species that remained isolated while neighboring civilizations advanced often found themselves increasingly marginalized and vulnerable to cosmic events beyond their ability to control. The message provided specific timelines for humanity's decision-making process. The coordination would monitor human development for the next 50 Earth years, allowing time for social adaptation and gradual technology implementation. During this period, additional contact devices would be available if humanity demonstrated readiness for more advanced guidance. However, the communication made clear that this was humanity's optimal window for joining the galactic community. The coordination's resources were finite, and species that failed to make the transition during their contact period typically faced centuries or millennia of isolation before receiving another opportunity for guided advancement. The transmission included detailed protocols for technology implementation that addressed many of the concerns that had divided human civilization. The recommended approach involved gradual integration, beginning with energy and materials technologies, followed by more advanced systems only after humanity had demonstrated ability to manage the social implications responsibly. Most significantly, the message revealed that the coordination would continue monitoring humanity's progress, even after 3I Atlas departed the solar system. The galaxy contained observation networks that could track the development of contacted species across interstellar distances, ensuring that guidance remained available for civilizations that chose the path toward galactic citizenship. The communication concluded with mathematical expressions that could only be interpreted as encouragement and confidence in humanity's potential. The coordination had contacted thousands of species throughout galactic history, and their evaluation protocols had identified humanity as having exceptional potential for successful transition to galactic civilization. The mathematical language conveyed concepts that transcended simple optimism to express something resembling affection or parental pride in a promising student. The intelligence behind the message had observed humanity's scientific achievements, cultural diversity, and capacity for cooperation despite differences, and had found qualities that suggested readiness for membership in the galactic community. As the final transmission concluded, and 3I Atlas began its communication shutdown sequence in preparation for departure from the solar system, observatories around Earth recorded the end of humanity's first extended contact with galactic intelligence. The contact device had delivered its message, provided its technological gifts, and completed its evaluation of human readiness for cosmic citizenship. The subsequent silence from 3I Atlas was profound but not empty. The visitor had accomplished its mission of contact, education, and evaluation. Now the responsibility shifted to humanity itself to determine whether the species would embrace the opportunity for guided advancement or choose to remain isolated until it developed the social maturity necessary for galactic citizenship through its own efforts. Dr. Marco Micheli, reflecting on the completed contact sequence, noted that humanity had been given the greatest gift in its history, not just advanced technology but membership in a community of intelligence that spanned the galaxy and offered guidance developed through billions of years of collective experience. Yet the gift came with responsibilities that would test every aspect of human civilization. The technologies could solve humanity's greatest challenges: energy, resources, environmental degradation, and the limitations of planetary existence. But they required social evolution that matched technological advancement, wisdom that could handle power beyond current human experience. As August progressed toward September and 3C Atlas disappeared into the cosmic deep, humanity faced the most important decision in its history. The choice was not simply about technology, but about the kind of species humanity would choose to become: isolated and limited to planetary existence, or connected to galactic intelligence and capable of participating in the cosmic community that guided the evolution of life and intelligence throughout the universe. September 2026 arrived with 3I Atlas now beyond the orbit of Neptune, its transmissions reduced to faint signals that required the combined sensitivity of Earth's most powerful radio telescopes to detect. The contact device had completed its mission and was beginning its final acceleration phase toward interstellar space, carrying with it the accumulated data from humanity's first contact with galactic intelligence. The silence that followed the end of active transmission created a profound void that forced human civilization to confront the most momentous decision in its history without further guidance from the intelligence that had offered membership in the galactic community. In the months since the revelation of 3I Atlas's true purpose, humanity had made remarkable progress in verifying and beginning to implement the transmitted technologies. International research consortiums had successfully tested materials, science applications that produced substances with properties exceeding every previous engineering achievement. Early fusion power experiments based on the transmitted specifications had achieved controlled room temperature fusion reactions that generated energy outputs far beyond chemical combustion while producing no radioactive waste. The implications for global energy production were revolutionary, promising to eliminate scarcity and environmental degradation within decades. Yet the social and political challenges of implementing such transformative technologies had proven even more complex than the technical obstacles. The potential for economic disruption, social inequality, and geopolitical instability created by rapid technological advancement had triggered international negotiations that revealed the depth of humanity's divisions about its cosmic future. The United Nations had established the Office for Galactic Transition, the first international body specifically designed to coordinate humanity's response to contact with extraterrestrial intelligence. Yet the office's efforts were hampered by national governments that viewed the transmitted technologies as opportunities for strategic advantage rather than shared human heritage. Religious communities worldwide continued to grapple with theological implications that challenged fundamental doctrines about humanity's place in creation. Progressive denominations had begun developing new theological frameworks that incorporated membership in galactic community as part of divine plan, while conservative groups maintained that human uniqueness required rejection of alien guidance. The scientific community had achieved remarkable consensus about the validity and potential of the transmitted technologies, but remained deeply divided about implementation timelines and social protocols. Some researchers advocated for rapid advancement to demonstrate humanity's readiness for galactic citizenship, while others warned that premature implementation could trigger civilizational collapse. Public opinion surveys revealed equally complex divisions within global populations. Younger demographics showed greater enthusiasm for rapid technological advancement and galactic contact, while older populations expressed concerns about social stability and the preservation of traditional cultural values. The economic implications continued to create uncertainty in global markets as analysts struggled to predict which existing industries might become obsolete and which new sectors might emerge from advanced technological capabilities. Investment patterns reflected both excitement about transformative possibilities and fear about disruptive change. Most significantly, early implementation efforts had begun to reveal the enormous social adaptation required for successful integration of galactic technologies. The fusion power systems required international cooperation on scales never before achieved, while the materials science applications demanded global resource sharing that challenged existing economic and political structures. The terraforming technologies transmitted by 3i Atlas offered solutions to climate change and environmental degradation that could restore planetary ecosystems within decades. Yet the implementation required global coordination and long-term thinking that exceeded the capabilities of existing political institutions and decision-making processes. Dr. Avi Loeb emerged as a leading advocate for systematic implementation of the transmitted technologies through carefully managed international programs that prioritized social adaptation alongside technological advancement. His approach emphasized gradual change that preserved social stability while moving steadily toward the capabilities necessary for galactic citizenship. Opposition voices continued to warn that humanity lacked the social maturity necessary for responsible management of technologies that could transform civilization overnight. Critics argued that the species' history of conflict, inequality, and environmental destruction demonstrated inadequate wisdom for handling capabilities that could either solve or catastrophically amplify these problems. The debate reflected deeper philosophical questions about human nature, social progress, and the desirability of guidance from intelligence that operated according to principles and motivations that remained ultimately alien to human understanding. Some viewed galactic contact as humanity's greatest opportunity, while others saw it as a threat to human autonomy and cultural integrity. As September progressed toward October and the first anniversary of 3i Atlas's discovery approached, the global conversation about humanity's cosmic future intensified. The technologies were available, The knowledge had been transmitted, and the invitation to galactic citizenship remained open. The question was whether human civilization could overcome its divisions and demonstrate the social evolution necessary to handle capabilities that transcended every previous technological achievement. The choice before humanity was not simply about accepting or rejecting advanced technology. It was about deciding what kind of species humanity would choose to become, isolated and limited to planetary existence, or connected to galactic intelligence and capable of participating in the cosmic community that had guided the evolution of life and consciousness throughout the universe for billions of years. The clock was ticking toward a decision that would determine whether humanity would seize the greatest opportunity in its history or remain trapped by the limitations and divisions that had characterized its development since the beginning of civilization. October the 1st, 2026, marked exactly 1 year since 3I Atlas had reached perihelion and begun revealing its true nature to humanity. As the first anniversary of active contact passed, the interstellar visitor had become nothing more than a fading point of light beyond Pluto's orbit, accelerating toward the cosmic deep, with secrets and capabilities that had transformed human understanding of its place in the universe. Yet the legacy of humanity's first contact with galactic intelligence continued to reshape civilization in ways that would have been unimaginable just 2 years earlier. The technologies transmitted by the contact device had begun the most profound transformation in human history, while the knowledge of galactic community had forever altered how the species understood its cosmic significance. The first fusion power plants based on 3I Atlas specifications had achieved commercial operation in 12 countries, providing clean energy that eliminated carbon emissions while producing power outputs that exceeded traditional nuclear reactors by factors of hundreds. The energy revolution was proceeding faster than even optimistic projections had predicted, with global energy scarcity becoming a problem of the past rather than a challenge for the future. Materials science applications had revolutionized manufacturing and construction industries worldwide. Buildings constructed with transmitted specifications displayed strength and efficiency that approached theoretical limits while requiring only abundant raw materials. The new materials had eliminated resource scarcity for most human applications while enabling engineering projects that had previously been impossible. The terraforming technologies had begun restoration of damaged ecosystems on scales that exceeded the most ambitious environmental programs of the previous century. Atmospheric processes based on transmitted specifications were reversing climate change while restoring biodiversity to regions that had been considered permanently degraded. Yet the social transformation required for full integration of galactic technologies remained incomplete. International cooperation had improved dramatically in response to shared challenges of implementing advanced capabilities, but fundamental political and cultural divisions persisted. Humanity was advancing technologically while struggling to evolve socially at the pace required for true galactic citizenship. The religious implications of contact with galactic intelligence had triggered the most significant theological development since the scientific revolution. New spiritual frameworks that incorporated cosmic community and guided evolution had emerged alongside traditional doctrines, creating religious diversity that reflected humanity's expanding understanding of its place in creation. Educational systems worldwide had undergone revolutionary changes to accommodate knowledge that exceeded previous scientific understanding by centuries. Universities had developed new academic disciplines focused on galactic technologies, while elementary schools began teaching cosmic citizenship alongside traditional subjects. The economic implications of advanced technologies had created both unprecedented prosperity and significant disruption. Traditional industries had become obsolete virtually overnight, while new sectors emerged that operated according to principles that transcended previous economic models. The transition was generating wealth beyond historical precedent, while requiring social adaptation that challenged existing institutions. Most significantly, humanity's understanding of its cosmic significance had undergone fundamental transformation. The knowledge that intelligence existed throughout the galaxy and had been guiding technological development for billions of years had replaced anthropocentric worldviews with cosmic perspectives that emphasized cooperation, wisdom, and responsibility for nurturing emerging civilizations. The psychological impact of galactic contact had been profound, but varied dramatically across different populations and cultures. Some groups embraced cosmic citizenship as humanity's natural destiny, while others struggled with existential implications of being students rather than the pinnacle of cosmic intelligence. Dr. Marco Micheli, reflecting on the year since active contact had ended, noted that humanity had demonstrated remarkable adaptability in integrating technologies that exceeded every previous achievement. Yet the species continued to struggle with social evolution that matched technological advancement, particularly in areas of global cooperation and long-term thinking. The monitoring presence of the coordination remained invisible, but presumably continuous. Humanity had been given 50 years to demonstrate readiness for full galactic citizenship, but the evaluation criteria remained unclear beyond general principles of cooperation, wisdom, and ethical development that transcended immediate tribal interests. As October progressed toward November and humanity entered its second year of post-contact development, the species found itself in a unique position in cosmic history. It possessed technologies that could solve every material challenge, while struggling with social and psychological adaptation that determined whether those technologies would elevate civilization or destroy it through misapplication. The legacy of 3I Atlas extended far beyond the technologies and knowledge it had transmitted. The contact device had forced humanity to confront fundamental questions about intelligence, purpose, and responsibility that would shape the species' development for generations to come. The cosmic messenger had delivered its message and departed, but its impact would continue expanding through every aspect of human civilization until the species either achieved the social maturity necessary for galactic citizenship or learned through failure that technological advancement without corresponding wisdom could lead to outcomes far worse than continued isolation. The choice remained before humanity, not just about accepting advanced technology, but about becoming the kind of species worthy of membership in a galactic community that had nurtured intelligence and guided evolution throughout the cosmos for billions of years. In the end, 3I Atlas had accomplished its mission perfectly. It had provided opportunity, knowledge, and guidance while respecting human autonomy and the fundamental principle that each species must choose its own path toward cosmic citizenship. The rest was up to humanity itself. Tonight, as astronomers around the world point their telescopes toward the fading light of 3I Atlas disappearing into interstellar space, they witness not an ending, but a beginning. The cosmic messenger has departed, but its legacy continues growing within human civilization like a seed planted in fertile ground, waiting to discover whether it will flourish into something magnificent or wither through lack of the wisdom necessary to nurture gifts that transcend every previous achievement in the long history of human striving. The evidence no longer whispers but resounds clearly. We are not alone, we are not the most advanced intelligence in the universe, and we have been offered membership in a community that spans the galaxy and operates according to principles of cooperation and wisdom that challenge our deepest assumptions about what is possible. The question is not whether we are ready. The question is whether we will choose to become ready, and in doing so, transform ourselves into something far greater than we have ever dared to imagine. The universe is waiting for our answer,